Uh, Good afternoon, ladies and gentlemen. Especially, I like to say hello to all young researchers because this afternoon session will be on the Atrans Young Researchers Forum, in which many of you will present your papers here. On behalf of Atrans, I'd like to start this afternoon session by inviting the the special lectures which will be delivered by Professor Dr. Alexis M. Filonay from the University of Philippines. May I invite Doctor, please?
Okay. Hello. Can you hear me? Hello, everyone. So, anyway, this is the first session of the Atrans Young Researchers Forum, and I will be presenting a special lecture on this title, Sustainable Local Public Transport Planning through an Academe-Industry Government Collaboration in Visayas Region, Philippines. So basically, this is the flow of my presentation. I'll start with an introduction, the objectives of the research, methodology. So this presentation will focus more on the training activities between the three and some initial findings. So for the background, we have this research project funded by the Department of Science and Technology, which we call Sustainable Technology Assisted Route Planning for Region 6. So the objective is to support the development of a sustainable local public transport route plan that will integrate air, road, and maritime transport in that region. And I will focus only on the one component, which is to train and provide both the software and hardware public transport planning tools to the local government and the university faculty. So these are the this is the location. If you have been to the Philippines, it's somewhere in the middle. Sorry, it's not moving. It has a population of 7.9 million by 2020. It's somewhere in the middle. This should be moving, but it's not moving. So anyway, so what we are trying to do is to integrate the route plans from the town, city, province of the region, from land, water, and air transport. So this is really collaboration between these universities, the national and local governments, as well as even drivers and operators, so that it will benefit the society. So this is the objective for this component only, is to develop a research partnership among the three and to address the transportation problem in Western Visayas. So in this presentation, I will only discuss the capacity building and training program, then their initial opinions, lessons, and findings, and also to discuss factors that may hinder or facilitate the implementation of the research partnership. So overall, this is the overall methodology of our research, but my focus is only on this aspect. So we also develop training manuals, also of course do the data gathering, the standard data needed to plan the whole region, and we also develop transport technologies like bus scheduling tool, economic assessment tool, and even the Android public transport tracker. But my focus here is on this aspect in this presentation, given that we have a short time. So we have this partnership. So there are 7 universities. There's 2 in Iloilo City, and 6 local governments, city and provinces, with the expectation that the trained LGU staffs are able to easily update and sustain the route plan of the respective province and city, while the university can help these local government units to sustain the planning process, because we have just introduced the PUV modernization program. So we give them the software as well as some hardware like laptops to run the software. Okay, so we did trainings. So it so happened that at the start of the project in 2020, we have the COVID pandemic. So all our trainings were in Zoom for year 2020 and 2021. And from one of the trainings, we expect our trainees expect high expectation from this project. So more than 60%. And we have here a good mix of participants in terms of educational background, planning, engineering, math and statistics, also accountancy, and also in terms of experience. So we have a good mix from young and senior staff and faculty, but there were more males than females, and more from the academe, more or less. Okay. So anyway, they also mentioned that the webinar is useful to the participants, and trainers' materials used are effective and organized, but there was not enough time. So in this case, I think this is a 3-day training, and there was not enough time to absorb, I think, how to plan and run the software properly. And there was positive response regarding their understanding, and they say that they will really need the software in their developing their local public transport route plan. Agree or strongly agree. So that was in year 2020. Then just this year in May 2022, we again did continuously the training, and again more than 60% joined from the academe, and again more or less the same mix of trainees who were involved. And okay, so in this part we use the software. Of course, we use the modules and train them. And if you are familiar with the EME transportation planning software, that's the software we are using. And as we can see, there's a 50-50 split between those. The dark blue are the positive response, while the orange, reddish response are the not so good with the software. But there are some who are really good in learning the software. And in terms of training materials in our organization, they are still okay with how we conducted the training. But there were, again, some disagreement on pacing and duration of the training. So again, because of the online training, we tend to fast track the training. So just to summarize, in 2020, we have 3 online training, as well as in 2021 with this number of participants. So there were no face-to-face training. However, in 2022, we have 3 online training and 3 face-to-face training. So in year 2022, this is more directed training, and we have only a few number of participants with hands-on use of the software. So I think this is the last slide. So the COVID pandemic considerably delayed research activities in this project. In particular, the research collaboration between the LGU and the universities, because we have to do all on online for year 2020 and 2021. But we can see that there is high expectation from the collaborators, and they really know how they will need the software in their planning and solving problems, transport problems in the region. And the online trainings have provided avenues to conduct training activities, and currently this year 2022 we are doing face-to-face and several up to December of this year, because the project will end this December 2022. And the sustainability of this research on public transport route planning can only be assured if the local academic institutions will be able to learn the route transit planning. Because after we ended the project, we are hoping that the local academic institution will help the local governments in their preparation of the public transport route plans. So anyway, this is a DOST funded project, and we also have several from other departments who are doing other parts of the components of the project. And I think that will be all. Thank you. So how much time do we have for the Q&A? Yeah. Still have time? 14. How many more time? Do we have questions from the audience? Maybe we can accommodate one or two questions. So we don't accept from Facebook questions? Yeah, we don't have. So, if there are no questions, maybe we now proceed to the first or the second presentation under this session. And so take note that you only have around 7 to 8 maximum, and you have 2 to 3 minutes of Q&A. So the next presentation would be about the redesign the tourism routes after COVID-19 pandemic, case study in Wang Nam Klao Sub-District, Nakhon Ratchasima Province, Thailand, by Assistant Professor Dr. Athapon Ariarit. So please.
Okay, good afternoon, everybody. My name Dr. Athapon Ariyalit, come from Suranali University. I will present our research, redesign the tourism route after COVID-19 pandemic, a case study in Wang Nam Hieu, Sub-District, Nakhon Ratchasima Province, Thailand. And this is the outline of our presentation. At first, I will talk about how our research come and how important of our research. Then I will introduce a little bit about the objective, then methodology and results. Finally, about the discussion and conclusion. Okay, at the first time, why we focus on the Wang Nam Hieu district? Okay. You see in this map, okay. The Wang Nam Hieu district is close to the Khao Yai National Park and Wang Nam Khieu district is very known as the world's seventh largest source of ozone in as eastern Switzerland. We can call that. Okay, so in general, we previous the COVID-19 situation. Okay, most of tourism want to travel in Wang Nam Khieu. So, what is the most activity in Wang Nam Khieu? The tourists like to see the mountain, okay, and go to the maybe mountain climbing or another things. Okay, so this is why we focus on the Wang Nam Khieu district. So now we preparing what happened after the COVID-19 situation, how the tourism in Wang Nam Khieu is changed. So this is the research objective. The first is to support the tourism in Wang Nam Khieu area, especially tourism after the COVID-19, and allow tourists to have more information about tourist attraction in Wang Nam Khieu sub-district. Second, to increase the value in the local area and stimulate the economy of the Wang Nam Khieu sub-district. Finally, to design travel itinerary according to tourist needs by applying programs for route planning, designing, and logistical principles to route organization. This is our research methodology. The first step, we need to find the factor, study the factor, affect to the decision for the tourists in the local tourism. Okay. Then the second step is design the travel route based on the previous information. And we will design and develop the media prototype. After that, we can redesigning the travel route based on the actual investigation. For the first step, study the factor affecting the decision of tourism in local tourism. We do the survey, okay, and in our survey, we can collect 1,007 respondents in the survey. And in this table show the briefly data from our survey. So we can conclude that about this. The second step, we deciding, okay, our route from the result of our survey. After that, we can know what the tourism want. The first thing, okay, the tourism want the budget hotel. So the hotel and resort are excluded from this alternative. Then we planning. Okay, after that we find the optimum route by using the based on the logistic principle by using GAM program and using the traveling salesman problem to find the shortest path. Okay. After that, we go to survey our route and we know some problem. Some problem is for example for some place is already closed due to the COVID situation, or some place we can go only in for some place we can go it's open only in winter. Okay. After that, we need to redesign our route. So this is our conclusion. The traveling tourist place include 2 camping paste are closed because the COVID-19. Okay. Sorry. Okay. So discussion and conclusion. Our research proposed the concept idea for designing the travel route using the study at Wang Nam Khieu sub-district, Nakhon Ratchasima province. The travel routes are designed based on logistic principle and tourist behavior. Tourists nowadays pay attention to nature tourism, especially after the COVID-19 epidemic. Therefore, designing the travel route by integrate culture tourism and nature tourism is one strategy to support community tourists and increase opportunity to promote a better local economy. So finally, based on this finding, the research discovery are witnessed in outdated internet tourist information. Some locations are listed on the website, even if they are closed. Okay, thank you very much.
Okay. Yeah, thank you, Dr. Narucha, for the very interesting presentation. So, are there any questions from the audience? So we can accommodate one or two. Yeah, please.
Okay.
Please state your name and affiliation, please.
Thank you very much for your presentation. It's very interesting to see how the impact of the tourist route to impact the environmental. I have a questions based on your findings. So based on your findings, what is your proposals? What is your recommendations of reroute and how it will impact? Yes, thank you.
Okay, can you show my slide? Okay, based on our information, okay, which route is recommend is depend on the tourist. Okay, sorry. So in our purpose, we have 5 category for the tourists. The first category is camping. Where is the location of the camping? The next is about the culture tourism, nature tourism, farm, and cafe. So this based on what the tourism want. Okay, thank you very much for your question.
Yeah, I think for the interest of time, we would like to thank Dr. Narucha for a very interesting presentation. Yeah,
Okay,
please
thank
give
you
a
very
big
much.
hand to Dr. We now move to the next presenter. The next presenter will discuss about the development of the depth-first search algorithm for solving the linked nested logit model in traffic assignment problem by Dr. Thiem Thien Bui. May I call? Oh, yeah. Please.
Good afternoon, everyone. I'm Tim from University of Transport and Communication, Vietnam. Today, I'm very pleased to be here and present about my research topic, development of the depth versus algorithm for solving the linked nested logit model in traffic assignment problem. My research is my presentation is divided into 5 parts. From part 1 is research motivation. Part 2 is some description about the current problem. The next is algorithm proposal. The fourth is application, and the final is some conclusions. As you know, one of the important directions to solve traffic congestion is the focus on traffic planning, in which the traffic assignment is a key component. As a well-known MNL SUE traffic assignment with the overlapping problem, although widely used, has also been criticized. To solve this problem, the linked nested logit model with the flexible correlation structure, keeping the closed form of the MNL model, is valuable in solving the overlapping problem. However, the choices generation and the method of MNH makes this model face memory occupancy and calculation time problems. So in this research, to increase the application of the MNL model, I will propose the algorithm without using the route-based variables and applies the method to fasten the convergence rate of the SUV solution. As can be seen from figure 1, shows the root overlapping problem of the MNL model, and the flows on overlapping roots as overestimated. I mean root 2 and root 2 and root 3 in this figure. And to solve this problem, the NNL model, considering two-level tree structure using the marginal and conditional probabilities, has been proposed. As can be seen from figure 2, shows the net structure of the NNL model in this small network. And if we use NNL model and MNL model into this small network, the root probabilities can be shown in table 2, table 1. And the ring-netted logic model can solve the root overlapping problem. I mean the probability in choosing root in root 2 and root 3. However, if we use the current NNL model, a fixed point problem with root flow of the SUE ring-netted logic model traffic assignment must to be solved as machine from equation 1. To solve this equation and achieve SUE solution, we must use to MSA method and must to enumerate and store all alternative roots. It costs the root, it costs the memory occupancy and the calculation time problem. So in this research, I will think about how to solve this problem. And my first point is I will transfer to the equation of calculating root flow into the equation to calculating the ring flow. As can be seen from equation 2, a fixed point problem with the ring flow of the SUE LNL model traffic assignment will be proposed. And in the previous research, I use the deficit algorithm into the MNL model. So in this research, I developed this algorithm and apply it to the NNL model, and means ring-netted logic model. And to solve this equation, the self-diluted average and the deficit algorithm will be proposed, and I only use ring-based and node-based variables to achieve SUE solution and shape memory, also calculation time. And figure 3 shows the calculation process of this research. As can be seen, we can achieve SUE solution by using the SI method and DFS algorithm, as can be seen from this calculation process. The next, I will apply the proposed algorithm into a small network shown in figure 4. It's a small network with 4 roots, and some parameters of this small network are assumed. And figure 5 shows the ring-nested structure of the small network. And as can be seen, the comparison between the old method using root-based approach and using the proposed method in this paper, the result shows that the proposed approach can accurately represent an NNL model and also saving calculation time. And the next is the application into urban RAD network. Some information of this network shown in this slide. As can be seen, if we use a DFS algorithm and apply it into an NNL model, the calculation time is also very small compared to the application of the DFS algorithm into MNL model. And also root-based approach cannot run in this application. So also the proposed calculation process is complicated. It still ensures very good computational ability. And in this application, because the number of OD pairs is quite small and the network is spread, so the problem of root overlapping is not very common in this case. So in the future, application into bigger cities with a high traffic volume will need to be carried out. So in this research on effective DFS algorithm for solving the NNL model in traffic assignment problem was proposed to save memories and calculation time. And in the future research, I will explore more about the structure of the model and further develop the combination of solving other problems of the MNL model. That is all my research. Thank you for the listening.
Thank you, Dr. Thiem. So, are there any questions? Buddha Sensei.
Thank you.
As a result, how many percent of the calculation time you can cut, and also how many percent you can save the storage? Yes,
Thank you for the question. Can back to the slide? Is application too small? Next slide. Next slide, please. Yeah. Oh, no. Next slide. Next slide. Slide 10. Next. Yeah, here. I applied the calculation process proposed in this paper into a small network, and in the application to the small network, the calculation time is saving, and the saving time is at least 94% in the application to a small network. And the next is the next slide, please. The next, in this, and in the application into real right network, if we use the root-based approach, because the number of root connecting this ODPS is very large, so the original root-based approach cannot run in this application. So only the proposed method in this paper is run, and the calculation time is very good in this application. Yeah, this is my results in this application. Thank you for the question.
Okay, we can accommodate one more questions. Are there questions from any question from the audience? Yeah, I think that would be it. Thank you, Dr. Thiem,
Thank
for
you very
a
much.
very nice presentation. So we now move to the third presenter. The topic is about development of a collision avoidance system for vehicles using 5G CV21. Presented by Mr. Warid Ditsayakarin. Please. Oh. Okay. Yeah, this is a video presentation. So this is through, of course, Zoom online presentation. So yes, please.
Afternoon, all of the audience. My name is Walid Khalin. I'm a graduate student from Faculty of Mechanical Engineering at Chulalongkorn University, who working with the Smart Mobility Research Center. Today, I'm going to present the research in the topic of development of collision avoidance system for vehicles using 5G CV2I. From NHTSA, FAR, and GS survey show that it have a lot of accidents occur on the interchange. It shows that the vehicle driving to the merging road have a high risk of accidents. As the autonomous vehicle of Smart Mobility Research Center route must be driven to the unsigned and merging road with the development of V2I in the present, it is necessary to invent a warning system to detect the on-road vehicle in the blind spot of sensor area, and is warning the autonomous vehicle, as you can see in this scenario. Next is the methodology. The preliminary warning system uses the camera detection and based on the SSD mobile net algorithm, but it has a problem when it is in the high dynamic range condition. That's cause we use the fusion of LiDAR and camera to reduce the problem and improve the performance of detection of the system. For the camera object detection, we use the YOLO for darkness loss. LiDAR object detection, we use the super fast and accurate 3D object detection. For LiDAR data receiving, we use the velodyne LiDAR method for sensor data decoding. For the detection system setup, first is the car detection area. As you can see in the picture, the only vehicle that we need to detect will be driving through the primary way. Then we separate the detection area into T-zone, and each zone have a distance about 14 meters. And this is the top view of the three zones, zone 1, zone 2, and zone 3. Next, we will see about the car detection system setup. We have set up the LiDAR camera and processing unit named NVIDIA Jetson. Next is the communication system setup. For testing the system, the warning display is attached into the testing car, and the GPS is set into the testing car to localize the car to subscribe the data from the detection system. As you can see in the map, follow the diagram. When the testing car driving into the alert area at the green point, it will be subscribed the data from the object detection system, and it can get the alert message until it leaves the alert area at the red point. The testing car will be subscribe the data from the detection system to the NetPy server. Next is the processing system of LiDAR and camera. For LiDAR, we use the super fast and accurate 3D object detection algorithm to detect the object in bird's eye view point count map, and its output the size and type of object to the bounding box. Next is the camera object detection. We use the YOLO4 algorithm to detect the object, and then we fusion the bounding box of LiDAR and camera detection to the intersect over union method. As you can see in the diagram, we detection in each zone and send the data to the notification system. Next is the test result. For the LiDAR test result, it shows that the detection capability is insufficiency based on the actual detection experiment, and it has a less detection length and stability than is required. This due to the lower point density of VLP16 than the HDL64 that used in SFA-TD algorithm. As you can see in the graph, the velodyne VLP16 have a lower distance than the HDL64. Next is the camera detection test result. As you can see in the graph, it shows that YOLO4 have a higher detection capability than the previous work SSD MobileNet, but the average processing time is more than the previous work, about 100 milliseconds. For the communication system test result, it shows that the communication transmission average time is about 36 milliseconds. For the conclusion, at first it was found that CV2I system could be designed and developed. Next, it can be detection in the various types of vehicle and pedestrian on the road, and it can send information to warn the autonomous vehicle to be safe. Next, it can be processing and transmit data with 5G in an average time approximately 350 milliseconds. Although it's lower than the conventional detection system, but it is sufficiency for use in the car driving at speed 50 km per hour. For the future study, it can be deployed in another location, another situation, and more than speed limit than the 50 km per hour. Thank you for watching my presentation of this topic.
Okay, thank you, Mr. Warid. And I think Mr. Warit will be available online to answer questions. So, are there any questions from the audience? Yeah. Yeah, please, who doesn't say? Yeah, I think,
Thank you for your presentation. So anyway, how to evaluate the feasibility of your proposed approach?
Again, please.
How to evaluate your feasibility of your study, your system?
I have to evaluate the quality of my system for I test about I have older algorithm and it is delay more than the previous algorithm, but it is have a detect capability more than the SSD that can be detect the car in every zone that I set in the area.
did he answer your question? Who doesn't? Maybe to state it in a different way, how can we verify the results of your study? Something like that? Correct?
Just a comment, because many organizations and many people studied about the similar approaches. So if we show that your system is better than the others, so you have to show that something, the reliability of your system, okay? Because a very hot issue in the field.
Yes.
Please, thank you. That's a comment.
Okay, thank you. Another question from Dr. Nai.
Thank you very much for the very interesting presentations. I'm just curious about it is experiment or just the lab testing or something, and how would you test the vehicle, whether you use the conventional vehicle or autonomous vehicle in your experiment? Do you understand my questions?
In this experiment, I used the experiment is used a testing car for represent the autonomous vehicle.
Is that with driver or without driver?
And it's with driver, but it can receive the alert to imply in the next experiment we will use the autonomous vehicle, real autonomous vehicle.
Right, and you test this one within the Chulalongkorn University campus, right?
Yes.
So, there are so many, joints, the junctions. So I saw in your presentation and also in your paper that you test and the T junction. So how was, I guess you have some kind of testing of the sudden brake to find the collision, things like I saw you in your presentations. So how would you, I would say, how would you verify on? Oh, okay, somebody told me to talk slowly. Okay, so step by step. I'm curious about your experiment. When that car was driving through the T junction. So I'm curious whether you test the sudden brake system to avoid collision or not.
In this experiment, we will not do the emergency brake, but it will use in the future work.
All right. Okay. Okay. Very well. Thank you.
Yeah, thank you, Dr. Nai, for the question. So I think we would like to thank you, Mr. Warit, for a very interesting, and I think this is one of the hot topics as mentioned by Fukuda Sensei. So thank you. Let's give a big hand to Mr. Warit. And we move on to the last presentation for this session. So the next presentation is about effectiveness of policy incentives on electric motorcycle acceptance in Hanoi, Vietnam, by Dr. Trong Thi Mai Than. Yes, please.
So good afternoon, everyone. My name is Trương Thị My Thanh from the University of Transport Technology in Vietnam. And today is my great pleasure to join the Atrans 2022. And today I would like to present my research on effectiveness of policy incentive on electric motorcycle acceptance in Hanoi, Vietnam. And my presentation today will cover 4 major parts. Firstly, I would like to introduce a short introduction of the research background and research motivation. And then the methodology and data collection will be presented, major results will be discussed, and finally, the conclusion and recommendation will be reported. And for starting, I would like to talk about the ability of many Asian cities that electric motorcycle can gradually replace gasoline power in such cities. And different incentive policies have been implemented in Asian cities to promote the adoption of electric motorcycle. This incentive might include the subsidy for purchasing, operating costs, free parking, low electricity rate, and access to the bus line. Also in Vietnam, we have many incentive policies that the Vietnamese government to propose to enhance the capability of the producer to invest on the green vehicles. However, we can see that in the production, the selling percentage in Vietnam is decreased in 2019. And many international researchers have conducted their research on the possibility impacts of the incentive policies. For instance, in Germany, they also conduct the research and produce a subsidy for the operating costs and sales tax. And in France, they also propose the 10,000 euros to reduce to encourage people to buy the electric vehicles. For instance, in US, they also enforce the tax credit or the direct subsidy program in UK. Although different incentive policies have been applied internationally, the level of satisfaction with each policy differs. Especially the incentive policy for electric motorcycle acceptance have not been fully captured. And previous study focused on the purchasing, the subsidy at the time of purchasing, not the operating or the whole life cycle of the motorcycle, electric motorcycle. So electric motorcycle user satisfaction of incentive offering for the whole life cycle of the ownership and uses is important to better formulate the policy measures. So the study aimed to measure the effectiveness of the policy incentive on electric motorcycle acceptance based on the example of previous study on incentive policy and conduct experimental designs and analyze the results. The study investigated previous study on incentive policy applied to promote electric vehicles. We used different impact factors and analyzed model. And based on that, we used the experimental designs with 8 attributes, which the purchasing price, the cruise distance, and the the recharge direction to reflect the motorcycles as a product, and the subsidy for purchasing, battery warranty, charger equipment, subsidy for the road maintenance, and subsidy for the electricity costs. And we use such 8 attributes and divide it into 2 sets. Each set we use the purchasing price and purchasing subsidy as a common and divided other attributes to different sets to get the respondent easier to choose. And such attributes generate very large, huge combination. That's why we have to use the octagonal array to reduce the possibility of scenario. And finally, we have the 50 choice scenario for each respondent. And we use that for the design the questionnaire. And the multinomial logic model was used to analyze the data. And VZ1 and VZ2 are utilized using the standard logic probability composed from Z1 and Z2. And then we divide X coefficient to beta 1 to get the willingness to pay of the respondent and reset as the MZ1 and MZ2. And I would like to highlight the major results. And based on the analysis results for separate model and combined model, it shows that the factors related to the cost and time has negative coefficient. It means that the utility reduction when the customer consumes more. In the contrast, the subsidy has positive coefficient, referring the customer desire to get more subsidy and incentive. Related to the analysis results for marginal willingness to pay, it's interesting to see that the customer are willing to pay 19,000 Vietnam dong to reduce the recharge duration by 1 minute, and 27,000 Vietnam dong to increase the cruise distance by 1 kilometer. And also the charger equipment subsidy is important because they perceive it's important 2.3 times higher than it really are. And also when they receive the electric cost subsidy and subsidy for the road maintenance, it's interesting to see that it's higher than they really have. For conclusion, the result facilitate better understanding of customer perception of incentive for electric motorcycle to recommend relevant policy to promote electric motorcycle expansion, and incentive policy that allocate more funding to operational support rather than the purchasing will be more effective. And that's the end of my presentation today. Thank you very much for your listening. Thank you.
Yeah. Any questions from the audience? Yeah, very interesting and quite comprehensive research. Dr. Noi, please.
This is another interesting presentation on the policy intensive and electric motorcycle acceptance. I'm just wondering whether are there any electric motorcycle running on the roads already or still under policy implementation?
Currently in Hanoi, Vietnam, and also many other cities in Vietnam, electric motorcycles are currently running. That's why my research, I conducted the survey who have experience with driving motorcycle, electric motorcycle, because the policy incentive is they can understand more, not only at the purchasing time, but also during the operating life cycle of the motorcycle. It's more effective. Yes.
How much is cost for one electric motorcycle?
It depends. It depends. The lowest maybe 20 million Vietnam dong, around 1,000 US dollar, and the highest maybe 3,000 US dollar for one electric motorcycle.
Is it imported from China or some?
Also in the lower level is from China and the higher level from Vietnamese producer.
Oh, I see.
Because it depends on the battery, the technology of battery. Lithium is more expensive. Lithium battery is more expensive.
Absolutely.
And chargeable or change the battery or charging battery is different price.
Right.
This is more popular now in my country.
Do you know how many percentage of market share between conventional motorcycle and electric motorcycle in Vietnam?
Actually, at this moment, we don't have the real market share in Hanoi. But in the first slide, I have the most updated selling volume. The selling volume of the electric motorcycle in Hanoi, but it's reduced much in 2019 before the COVID pandemic. There's maybe different reasons for this reduction, because it's comparing with the purchasing cost is high, and also very high at the operating cost. And also the problem of the charging station. Charging station, the facility is not really good at this moment. That's why after they at the first time they interested in the electric motorcycle, but after that they realized that the operating cost is much higher than they expect.
I think this problem is SMS in Thailand too.
Yes.
I just would like to know, what would be your ultimate goal for the policy implication for your intensive program in this study?
Yes, that's why we believe that the subsidy incentive should be focused on the operating life cycle of the motorcycle, electric motorcycle, not at the purchasing cost.
I see.
It's more attractive and encourage people to willing to use the electric motorcycle. Concentrate on the operating subsidy.
Okay, good. Thank you very much.
Thank you very much.
Yeah, maybe we can accommodate.
Yeah,
Doctor,
I wonder about the accident. The accident. Yes, when government give more subsidy for the motorcyclists, how about the accident is increase or decrease? In case of Thailand, there are about 30 cases for the fatal accidents. More than half is from motorcyclists.
Actually, at this moment, we don't have the data comparing with the traditional motorcycle, the gasoline motorcycle, and the electric motorcycle. However, the accident, especially the accident between motorcycle and cars, have a highest potential in Vietnam. And also maybe it depends on the speed. The traditional motorcycle have maybe the longer distance to travel, and the time to increase the speed is higher, but the motorcycle is a little bit lower. But we didn't have any data about the possibility of the accident between the traditional gasoline motorcycle and electric motorcycle. Maybe it's the promising research in the future. Thank you.
Okay, thank you, Dr. Trong. I think for the interest of time, we will now end this session. So thank you again for the 4 presentations. Let's give them a big hand.
Thank you. Before going to session 1, part 2, I would like to ask our Honorable Advisor, Mr. Silapachai, to present a token of appreciation to Professor Alex for his kindness of moderating these sessions. That is the air purifier suitable for the COVID situation right now. Thank you very much. Thank you. Okay. Thank you very much. Yeah, you can use right now. Okay, so next, let's move on to the session 1.2. This session 1.2 will be chaired by Associate Professor Dr. Vera Medvichinsen from Kasetsart University. In this session, we have 4 presentations. Let me remind you that you have 7 minutes for presentation and just 3 minutes for question and answer. Make sure that you make presentation within the time given. Okay, let me give the floor to Ajahn Varamed, please.
Okay, let's move on to the session 1.2. In this session, we've got 4 presentations from the colleagues from the Philippines, from Japan, and also from the Vietnam. So let's move to the next presentation, presentation number 5, which is entitled as the Assessment of Intermunicipality on Municipal PUV Services in Southern Iloilo, the Philippines. Okay, this will be presented by Miss Eliana Austin. Okay, let's please excuse me if I pronounce wrongly.
Good day. This is our study entitled Barrier-Free Mobility Assessment of General Luna Street
I think because you just switched the new to the new presentation that you just realized, right? So it's quite consume time a little bit. So please take minutes for the moment. Okay.
Hello. Good afternoon, everyone. I am Eliarina Dolores Agustin, and I will be presenting my paper entitled Assessment of Intermunicipal PUV Services in Southern Iloilo, Philippines. So first, for the background of the study, the economic growth of developing countries like the Philippines is dependent on the transportation sector. So the Asian Development Bank conducted a study back in 2016, and they found that 77% of the population is expected to live in urbanized area in 2030. This is why the transportation sector should be improved. And with that, the government launched the PUV Modernization Program, also known as the PUVMP, in 2017. And one of its components, which will be the highlight of my study, is the Local Public Transport Route Plan, or also known as the LPTRP. So the LPTRP is the standards or what will be used in the study area. So next. So the study area or the district of interest where the LPTRP was implemented is Southern Iloilo. So Southern Iloilo is composed of 7 municipalities, namely Gimbal, Igbaras, Miagao, Oton, San Joaquin, Tigbawan, and Tubungan. So these municipalities, as shown in the figure below, is situated linearly or almost next to each other. So this one, with that, the analysis of the study focuses on a single corridor made of composed of 2 roads, namely the Iloilo Road and the national roads. So this one is selected because it aims to produce an analysis that will benefit most of the commuters in the area. So the existing services in Southern Iloilo is namely the collector, distributor, non-fixed fare transportation service operation, and the regular service. So jeepneys and UV Express operate as collector or distributor. Tricycles operate as non-fixed fare transportation service operation, and PUB or public utility buses and some of the UV Express operate as regular service. So collector or distributor stop anywhere along the road. Next are the tricycles, so they operate as auxiliary auto or taxi, are similar to that of the taxis, where they operate door to door, and they also board and alight passenger upon the passenger's request. And for the PUB and the UV Express, they operate from terminal to terminal. So next. With the existing scenario, we now proceed to the statement of the problem or the problem in the area. So the transportation in the Philippines, which includes the southern Iloilo, is dominated by competing operators and drivers. And with that, the loading and unloading is unorganized, or these are temporary zones. They can load and unload anywhere. Next, this also results to the oversupply of units, and aside from that, this also results to obstruction. So on top of that, the Metro Manila Development Authority was also asked to conduct a survey on the problems in Southern Iloilo or in Iloilo City in general. So the MMDA found that aside from the absence of permanent loading and unloading, obstructions and faulty terminals are also causing traffic. In top of that, the tricycles operate along the national road, which is in contrary to the Joint Memorandum Circular Number 1 of Series 2008 of DOTC and DILG. So with that problem, we now have the main objective, which is to assess and improve the current public transport service operation in Southern Iloilo. So the review of related literature, we conducted studies related, we investigated different research related to different transportation modes, category analysis, network modeling, and supply and demand in public transportation. So for the methodology, I divided into 4. So first is the data collection, next is the simple category analysis, and from the simple category analysis, the OD matrix and the MF4 modeling was done, or the network modeling was done. And from there, the proposal or recommendation and conclusion were formulated. So for the results and discussion, these are the results of the grand MTR, or the mean trip rate from the simple category analysis. So the mean trip rate was used to estimate the number of trips per municipality. So from there, we modeled the number of trips. So this is from the MF4 modeling. And from the MF4 modeling, the number of units, passenger demand, length of time travel, and the length of routes in kilometer were calculated. So we now proceed to the proposed scenario. For the proposed scenario, there are 3 types of services that were proposed: the feeder, local service, and the limited stop service. So for the feeder, we have the tricycles. Next, we have the local service. So this local service services stop at terminals and assigned loading and unloading zones. So these local services will be operated by field cabs and modernized jeepneys. And next, the limited stop services, which will be operated by modernized jeepneys as well, but this type of modernized jeepneys have bigger capacity, stop at terminals as shown in the figure. So this is from the MF4 model. And next, we have the additional comparison of the number of units for the existing and the proposed. So it was calculated using the RMC formula, which account for the passenger demand and the seating capacity. And then we have the comparison for between the travel time for the proposed and the existing, and the passenger demand between base model and the proposed scenario. So as you can see, it can be observed that the number of units as well as the passenger demand, there is an obvious increase in terms of quantity. And So yeah, on top of that, the comparison was also done using the different indicators, performance indicators included in the LPTRP standards. So there are two, the frequency and the utilization. So for the frequency, the total vehicle volume and the headway were compared, and then for the utilization, the average load factor was compared. So for the total vehicle volume, there is a decrease in the vehicle volume in the area, and for the headway, there is an obvious increase. So this means that in terms of these values, there is improvement. There is an improvement between the proposed and the existing. So the average load factor also increased. This should also be expected since we want to show that there is an improvement between the proposed and the existing. So lastly, for the conclusion and the recommendation, first, from the objective that is to assess and improve the transportation in Southern Iloilo, this was done using the SCA or the simple category analysis, and we also showed the improvement using the LPTRP standards and the MF4 modeling. So from there, the proposed services are more efficient and will replace tricycles operating along national roads. So the fill cabs that were proposed in previously will replace the tricycles, and based on the development models, the introduction of those services will show improvement, and performance on indicators also showed improvement. So for the recommendation, future studies can investigate the industry consolidation where operators can form cooperatives that can coordinate scheduling of trips and lessening the competition in the road. Research can be further improved by considering different establishments. And then next, the network model can be further improved by factoring in the travel cost, and personal characteristics and trip purpose of commuters can be further investigated by future researchers. So that's it. Thank you.
Okay, thank you very much. Because of time limitation, I think we can welcome just only one short question from the floor. Yes, please, Mr. Chairman.
Well, I think I have to admire your presentation. This might be the case for Thailand when they are doing any bus route allocation. They have to use some model, not just guessing. The question I like to raise is that how much does it cost to carry out this kind of study, and who sponsor it? Thank you. You know?
I think maybe, sir, I can list what will be included in terms of what should be included in the budget, but the exact amount can provide only an estimate, or is that okay with? Yes. First off, since we're using an MF4 model, which is also licensed, we should put that in the budget, how much it will cost for the license to be operated. Next, since in the collection of data, we also conducted household interview surveys, so it is most likely impossible for only a single person to conduct the household interview survey. So in terms of manpower, we should also allocate budget for that. And in terms of the collection of data in vehicle count, manpower should also be included in the budget. But yeah.
But maybe first Alex.
Yeah, maybe so I can answer the question. Yeah, because we have this research, but the survey was conducted by the local government units. They spent around 3 million pesos, but for the whole province, maybe in that case, half 1.5 million. But it's really cheap because we asked the help of local government units to help. So, and maybe for other activities around another 3 million. So we did it around 6 to 7 million pesos only, this exercise. Yeah, thank you.
Okay, thank you very much. Okay, so thank you very much. Okay, and due to the time constraint, I would like to move to the next presentation. Okay, the next one will be given by Sevilla from the University of the City of Manila from the Philippines. The title is Barrier-Free Mobility Assessment of the General Luna Street in Manila. Okay. Okay, this one will be online.
Good day. This is our study entitled Barrier-Free Mobility Assessment of General Luna Street, Intramuros, Manila. Walking has been man's primary means of mobility and the greatest social equalizer in the world. However, due to the rise in motorization, pedestrian facilities have been left behind. Further behind are the public facilities that should give access to persons with disabilities. In the Philippines, there are laws which set the minimum requirements for the design of facilities for accessibility. Intramuros is a district in the capital city of the Philippines, which is Manila, which has been recognized as Asia's leading tourist attraction. General Luna Street is one of its major streets linking various educational facilities, government institutions, historical sites, and religious landmarks. But observed are the following problems: roads within Intramuros that lack infrastructures for the disabled, government establishments, educational institutions, and historical sites not accessible to PWDs, and crossings within Intramuros that are few and deemed unsafe by pedestrians. This study aimed to first create an evaluation index based on the provisions of local laws, namely the Accessibility Law, locally known as Batas Pambansa Bilang 344 or BP 344, and the Department of Public Works and Highways Department Order Number 65, Series of 2013. Second is to assess the facilities for accessibility of PWDs for roads, buildings, and crossings in General Luna Street using the evaluation index. Third is to create maps of the facilities and a database for accessibility along General Luna Street with the application of Geographic Information System or GIS, and to evaluate the collected information and make recommendations to produce an accessibility enhancement plan for the improvement of the mobility of PWDs around General Luna Street. For the methodology, the evaluation index was adapted from the accessibility law and some requirements in DPWH DO number 65 to check if each structural element or facility for accessibility present along General Luna Street was compliant or non-compliant to the minimum requirements. The elements included in the evaluation index are dropped curbs, curb cutouts, walkways, handrails, signages, crossings, building entrances, and building ramps. The elements were evaluated according to the set of specifications they need to comply with in reference to the law. For the assessment, General Luna Street was divided into 9 road segments at their intersections with perpendicular streets, and a total of 9 buildings were assessed. An element is compliant if it passed all the specifications required. An element could be partially compliant if it passed in at least one but failed in other aspects, and should be categorized as non-compliant, since failing one requirement might compromise the overall function of the evaluated facility for accessibility. If none of the specifications are met, the element is therefore non-compliant. Using Quantum Geographic Information System or QGIS, an open-source mapping tool, in conjunction with OpenStreetMap or OSM and the add-on Merging for QGIS, using the application Input QGIS in Your Pocket by Lutra Consulting, coordinates of the elements were recorded in real time during data collection. With the data collected, an accessibility enhancement plan was created outlining the observed problems and the corresponding measures to be taken to enhance the mobility of PWDs in the research locale. For the results, using the evaluation index, it was observed that out of the 71 facilities for accessibility present during the assessment, only 14 facilities, or about 19.72%, are compliant with the law. These were the observations. Generally, the total of 6 curb cutouts present along the street were compliant. However, the amount of 6 curb cutouts for the 800-meter length of General Luna Street was relatively few. For the walkways, only 29.71% of the total walkway length, or about 447 meters, passed the required minimum width of 1.20 meters. There were obstructions in the route as well as surface cracks that protrude above the surface. Signages were uniformly designed and installed but failed to provide raised symbols and braille symbols to aid the visually impaired. There were also no signages indicated with the international symbol for access. All building ramps complied with the maximum gradient required, but 4 out of 6 ramps failed in the handrail requirements. For building entrances, 3 out of 9 buildings were not able to provide ramps due to historical preservation efforts and the lack of spaces with a limited area of the sidewalk. Crossings were generally few and lacked tactile markings within its vicinity. Unfortunately, all crossings failed to provide painted stop lines as required. The mapped-out facilities for accessibility were provided with photographs of the conditions of each element during the data collection. This should provide information essential for accessibility and PWD mobility. The study adapted the format of the Champaign County Regional Planning Commission in East Illinois in presenting the findings from the evaluation index and listing the corresponding recommendations to improve the facilities for accessibility. Compliance recommendations were formulated for the existing elements with the emphasis on the specifications provided in the law. Supplementary recommendations, on the other hand, were the outline of possible measures for the conditions, inclusions, and modifications to improve the PWD mobility within General Luna Street. For the conclusions, the evaluation index initially fulfilled the gaps in terms of compliance records of facilities for accessibility within General Luna Street through a standardized and systematic method of evaluation. The study has shown that General Luna Street has a compliance rate of about 19.72% for the facilities for accessibility. The parameters of the GIS database encompasses the spatial information and the compliance to the requirements of the law to form maps of the facilities for accessibility along General Luna Street. The Accessibility Enhancement Plan was incorporated in the Barrier-Free Mobility Assessment that could aid government agencies and administrating bodies in facilitating improvement plans for a safer and more inclusive society. That concludes our presentation. This has been Carmina Arce from the University of the City of Manila. Thank you very much for listening.
Thank you very much. So I think barrier-free facilities is quite important. So I would like to invite question and recommendation from the floor, please. I think we are talking a lot about the walkabilities, and barrier-free would be very important. Okay. Do you have any comments? Okay. If not, I would like, I myself have some questions. How did you calculate the index? You said 80% of the facility did not pass or did not comply with the standard, right? So did you weigh the factors together?
The evaluation index was based on the provisions of the law. The results from the evaluation index, first of all, the evaluation index is the collection of assessment forms which were based on the provisions. And then from the evaluation index, the results, which reflects the compliance or non-compliance of each of the facilities for accessibility present in the General Luna Street, were calculated using getting the percentage as compared to the total number of facilities that are present in the street.
Okay, and how about this location? Is it representative as a general case in the Manila?
General Luna Street is one of the major streets in Intramuros, which links various educational facilities, government institutions, including University of the City of Manila, and also Department of Labor and Employment, and also other historical sites and religious sites, such as the Manila Cathedral and the San Agustin Church. Also, along General Luna Street, you can find the Palacio del Gobernador, where the Intramuros Administration where the Intramuros Administration's office is located. So these very important sites can be found in General Luna Street. That is why also the researchers looks at it as an important
Right.
location.
So I'm asking, okay, I mean, is it better than average or worse than average? Is it better than
sorry,
average case?
In terms of the compliance rate,
Right,
are you the compliance rate of a total of 19.72% was relatively low for the street.
Okay, thank you very much. Okay, any other comments and questions, please? Okay, if not, let me join us to thank the presenter. Thank you very much.
Thank you.
And I'd like to welcome the next one. Let's welcome the colleagues from Japan, Mr. Kota Iwanami. Right. So he's going to present a paper title is a comparative analysis between net cost method and gross cost method. The case of Blue Line and Purple Line in Bangkok. Okay.
Hello, my name is Kota Iwanami, Nihon University in Japan. Today, I will present about my research, comparative analysis between net cost method and gross cost method, case study in Bangkok Blue Line and Purple Line. In the background, urban railways are being developed in large cities in Asia to avoid a worsening traffic congestion. However, many urban railway projects are facing financial problems, not operating being successfully. For example, in the Blue Line, it is in the red from the beginning of the operation. So it is necessary to consider what kind of management system should be adopted for the future success of urban railways. So in this study, developing financial analysis model for urban railway operation, which will apply the net cost method and gross cost method based on the scheme of upper and lower separation method, and estimating the break-even point and the year of time to break at multiple years. Then clarify which method is suitable for urban railway business operation. In the previous study, Morichi et al. Conducted a risk analysis and financial simulation of PPP projects for 3 lines in Southeast Asia. As a result, it was found that the financial situation is likely to be severe at the beginning of the project. Matsushita et al. Analyzed the risk in the planning, construction, and operation stages of each project using data from the Bangkok Blue Line and Manila Subway Line. As a result, they found that demand risk and fare risk have significant impact on each stage. So this is the research flow. First, setting up the budget route based on the Bangkok Blue Line. Next, creating a financial analysis model using system dynamics software called Bensim. Then, analysis and compare the break-even point and the year of time to break at multiple years. Break-even point means the year when current account balance into surplus in a single year. The year of time to break at multiple years, the year when accumulated deficit are finally eliminated. This is the multiple year, and break-even point is a single year. This is the line detail, such as operation kilometer, construction cost, bank loans, interest loans. This is the operation method. I will talk about the net cost method. First, semi-state enterprise operated the train, and state enterprise construct a railway. Semi-state enterprise getting a fair revenue for the operation, and semi-state enterprise pays a concession fee to state enterprise. In the gross cost method, state enterprise getting a fair revenue and constructed railway, and semi-state enterprise is only operated the train and getting a certain amount of concession fee. This is the model flow what I make. First, estimate the revenue and expenses for a single year. Then, sum up the revenue and expenses, a single year balance is calculated. After subtracting taxes, principal, and interest on long-term loans from single year's balance, the financial surplus and deficit are calculated. This is multiple. If it is in red, it's covered by short-term loan. This is the system dynamics model that I said before. The left side is semi-state enterprise, and right side is the state enterprise. In the net cost method, semi-state enterprise pays the right side to the state enterprise as a concession fee. In the gross cost method, state enterprise pays a concession fee to semi-state enterprise, its left side. This is the result of break-even point. Net cost method, semi-state enterprise in the net cost methods take 11 to 20 years rate. And state enterprise is beginning black from the beginning. Gross cost in the gross cost method, both of enterprise is black from the beginning. This is the result of the year turning into profitable at multiple years. Net cost in the net cost method, semi-state enterprise is in the red from 15 years to 46 years. And state enterprise is also in the red, and it takes 21 years to turn into black. In the gross cost method, semi-state enterprise is black from the beginning because they receive a certain amount of concession fee from the state enterprise. But gross cost method, it took 40 years to turn into black. This is the result after delaying concession payment. In this class, I compared with the existing net cost method, and 5 years delay at the concession fee payment of the net cost method. In the net cost method, it takes 11 to 20 years, as I said before. But if we delay the concession payment from 16 to 26 years rate, it is shortened about 7 years. And the state enterprise, both of the net cost method and delaying concession payment pattern is black from the beginning. This is the result of the year of time to black at multiple years. In the net cost method, semi-state enterprise is 15 to 46 years rate. But by delaying concession payment, it is black from the beginning. In the state of enterprise net cost method, it takes 21 years to turn into black. But if we raise a concession payment, it took 26 years to turn into black. In the conclusion, net cost method and gross cost method have their own disadvantage. In the net cost method, semi-state enterprise is in the red unless concession fees are waived after the opening. However, if the payment is waived, state enterprise may into deficit. In the gross cost method, semi-state enterprise gains stable profits, but the state enterprise on demand risk. If demands are small, state enterprise will be in deficit. In January, public owner have to bear the risk because of its high publicness. But still, like a Bangkok pink line and yellow line is used the net cost method. So appropriate risk sharing is necessary in the project. That's all my presentation. Thank you very much.
Thank you very much. And this again would be very important issues for the PPP project. So I would like to invite the comments from the floor or questions from the floor. It sounds quite a little bit difficult to comment at this time, right? But anyway, right. So in case of the blue line, okay, it seems very profitable from the initial sections, but from the purple line, I think right now it faces difficulties in terms of the demand, right? So for the blue line, it would be okay.
Yeah.
For the purple line, we have the quite very small number of demand, right?
Sorry, take a PowerPoint.
Okay,
please.
just turn back to your slide.
In the blue line, the single year balance is low, but in the purple line, single balance is stable because they get the concession fee. And yes, in the state enterprise, net cost method takes a high profit, but in the gross cost method, it's mean purple line, the profit is low rather than blue line. Yeah.
Right. Okay. Right. What I'm going to ask is, how did you use WinSim to simulate the risk? What kind of uncertainty did you simulate in WinSim?
WinSim?
Right. You use WinSim, right? WinSim, right? You use system dynamic, right? You put some uncertainty in the model, right?
Yeah.
Right. So what kind of uncertainty did you put uncertainty in the demand?
Yeah, I collect the data from the annual report, but I can't get the detailed data from the purple line because the data is not open for the public. So, yeah, I use the data from the my senior student, my doctor student. So I think it is okay to compare each new method, net cost method and gross cost method, but this data is not correct, I think. But I can't compare each method.
Okay, let's continue discussion later. Okay, thank you very much. And the last presentation in this session would be the colleagues from Vietnam, Dr. Tran. Okay. So his presentation will be on the research on the applicability of the shared parking model in the downtown area of Hanoi.
Good afternoon, everyone. Before my presentation, I would like to express my big thanks to the Atrans to give me opportunity to come here to present our research result. The title of our research result is research on the applicability on the shared parking model in the downtown of Hanoi. On behalf of our group, and my name is Nam, full name Chinoy Nam from the Duy Tân University in the Da Nang city in Vietnam, in the central of the Vietnam. And during the 7 minutes, I will try to transfer the key research result of our research. With our outline of my presentation, first I will start by the introduction and then talk about the shared parking model, and next about the research methods, and then I will focus on analyze the parking status in Hanoi, downtown Hanoi area, and then I will move on the orientation to the shared parking model, and the last one is about conclusion. And for the introduction, as you know, now in the not only in Hanoi but other big city in the developing country, the big problem is about the parking areas. And you can see in the picture here, you can see almost the parking area right now. It's almost the sidewalk, and most of them about the illegal parking areas. And the three key issue about the parking infrastructure in Hanoi right now is about the high demand. It's high demand for the parking and limited land fund for the car park, and the last one is the lack of the parking space in the central area. I think this one is the three key main issue for the parking infrastructure right now. And then that's why we can conduct the study about the safe parking model. And as you know, the safe parking model is the solution. It can be understand that similar to how to the sharing the room or sharing the vehicle parking. And the development of safe parking model is based on the advantage of the supply, improve the exploitation in efficiency and use through the super application of information technology. And shared parking model, it will help the user focus on the driver to avoid taking a lot of time to find parking lots or find a place to park the car. And the shared parking model is based on the IoT information technology, and it helps to connecting the vehicle by the smartphone or some sensor in the parking lot area. And the safe parking model can help driver look for the vacant parking lots and allow the owner of the parking space could update the vacation parking situation on the safe parking model system. And in our research, we conduct the research methodology include three main parts about the overall reviews, data collection, and the survey. For the survey area, we focus on the 4 streets in the downtown area of Hanoi, in around the Hoan Kiem Lakes. And also for the beside the 4th street, we also survey for the parking needs in the some in the office or commercial area around the 4 streets. And for the first street is Hai Ba Trung Street. We can see the high demand parking area in almost in the morning and in the afternoon, from the 4 p.m. to the 5 p.m. And for the Hang Tre Streets, the high demand, the peak parking demand in take place during the morning around the 7 a.m. and in the morning it's around the 6 p.m. For the Trang Thi Streets, we could see we got the commercial activity in Hang Thi Street is quite different from the the 2 periods of streets. So the demand, the parking demand also the different. Yeah, similar to the Nguyen Hưu Huan streets. And also for the commercial area and around the 4 streets, we also survey for the parking needs in these areas. And we could see the time for the parking demand also the different. Yeah, it focused the high demand in the morning from the 9 a.m. to the 11 a.m. And for the orientation for the safe parking application, because in our research, in the first stage of our research, we did conduct the survey. So we could recommend some the orientation for the safe parking application in downtown of Hanoi area. We need to combine of the 3 key stakeholders, about the vehicle owner, for the car parking owner, and also the management agency, and almost the government. And for the conclusion, we could see that the providing necessary facility at the parking lot is important, like the sensor, the surveillance camera, and a safe parking model can also integrate the owner of parking lot to monitor the operation and car using in this model. And to apply the safe parking model effectively, it's necessary to have other study. And this study is the first step of our study. And next we could conduct another the research focus on the shared parking application. Yeah, that's the key result of the research. And to help to continue our research, I hope to get some comment from the regulator in this conference. Thank you.
Thank you very much. So this one is also the emerging issues, very important issues in the big cities in Asia, right? Yeah. So I would like to invite very short question from the floor. Okay, please, Professor Alexis.
Average duration of a vehicle, how long they park on the average on the street?
For our research, is for how long you mean the parking, right? The time for the
like
parking.
Average per vehicle, how long they park?
For the that's the time for almost the different. It's different from the street for another street, but every time it around 1 hour to 2 hours. Yeah.
And
but for the commercial area or something, it's more the time is more the longer.
Long term.
Yes.
And you charge now parking? You charge like how much per hour or something? Do you already charge?
Right now in Hanoi or another city in Vietnam already the charge take the charge for the parking on the roadside. Yeah.
For malls, do you also charge? Parking building.
5,000. Yeah. It's 25,000. Yeah.
So because you can use charging to manage.
Yeah.
Thank you.
And may I have very short question continuing to this one? Is it how about the charging system? Is it centrally charged? or depends on the owners of the parking lot?
This one, you mean the
one who charge
it's
the drivers?
right now the government. It
Government
now,
charge,
yeah, in my
okay.
city, in my city, the government city.
Okay.
Yeah.
Right.
But I think for the share parking, maybe could combine the government owner and also the private owner.
Right.
Yeah,
right.
could be combined.
Right.
Yeah, to provide the parking area for the driver.
Okay.
Yeah.
Right. Okay. Thank you. And maybe the last question from Professor Widot, please.
Do you include the off-street parking or only the parking on the road?
And right now it might focus on the parking on the roads and the parking around the building, like the commercial building for the residential area. Yeah, and I think shared parking could apply for that kind of the parking area. Not only the road side, not only on street parking, also need the parking for another area, like the commercial area, like the residential area. Yeah.
How to collect money when they charge?
Like for the roadside, I think if the charge will come to the government, but for the another area like the private area, like the commercial area or the regional area, I think it's like the private sector, like the owner of that the building, that area, they will charge that share parking fee.
When the governor charge the parking,
yeah,
do they explain how to spend the money that collected from the parking charge?
Yeah, because like the share parking model, it's based on the IoT, like based on the app. We have apps. We have the apps on the smartphone, and we use that the app. We could know where I could find the area to parking, right? Because the parking owner will give update the information on that app, and the driver could find where the driver can park the car, their vehicle, and they could pay by the online or maybe by the cash in that area.
Yeah, I mean after the government collect the money.
Yeah.
How do they use the money? Use for what purpose?
Yeah, that's in the key the interesting question. I think the key issue right now.
Yeah. If people don't know where the money gone, so how do they need to pay?
Maybe I think that's money could, because we have a limitation, like we need to pay, the driver need to pay the money for the car parking. So I think the government could use that money to invest from other infrastructure, like invest onto the public transportation, something like that.
You know, some country, for example, in Taiwan, they spend the money for the non-motorization.
Yeah.
They use the money to improve the public transportation.
Yeah.
That's a good way that people can understand, and they like to pay more.
Yeah.
Otherwise, they don't want to pay. Why do they need to pay? They have to answer. Okay.
Yes.
The government. That's a key point.
Yeah.
Thank you.
Yeah. Thank you for the recommendation and.
I think this is very critical issues
Yeah.
In the big city. Okay, thank you very much.
Yeah, thank you.
I'm very sorry that we are quite behind the schedule. So I'd like to thank all the excellent 4 presentations for today. And I believe that the session will be also continue to the session 1.3, which will be handled by Dr. Ratanaporn.
Before going to start the 2.1 session, allow me to invite our honorable chair, honorable advisor, Mr. Silvachai, to present token of appreciation to Associate Professor Dr. Varamed Vishensan for the excellent moderating session. Thank you very much. ขอบคุณค่ะ อาจารย์ Next, I would like to invite Assistant Professor Dr. Ratanaporn Kasemsi from Suratnara University of Technology to deliver a special lecture on the utilization of drones for accident data collection in Thailand. Just would like to remind you, you have 10 minutes.
10 minutes.
Yeah, 10 minutes, please.
Good afternoon, all participants. I would like to just share what we have did in our university. Today, I would like to talk about drone, but I think all people have no drone already, right? Let's see from the definition first. The drone have a definition as they don't need the people who sitting in the aircraft. That we definition for the drone. And this is the drone that our university tried to develop and build. We have actually, let's review for Sulanari University. We was attribute for the dominant in the engineering. And we have nautical engineering also. So we try to develop our drone by ourselves. And to operate on the drone, we have actually 4 sectors for the equipment that we need. Of course, we have the aircraft, right, at the first one, and we need the sensor or the camera that we need to use for collect the data. And the next one, the application, I mean the software to analyze that data that we have collect. And finally, about the programming to use together with the software. And here is actually the type of the drone that have exist in our world. Actually, they actually have mainly about the multi-router and fixed wings. The multi-router, like you have a router that can spin and then they can fly. But another thing is a fixed wing that you can use the motor to run the drone. And about the utilization, in a lot of fields that we use in recently in our world, in our global. For example, our university also run on the agriculture help. Like we help many of the agriculture part to spread out the nutrition of the plant, and we also have apply for doing the mapping. The mapping in our university also make it at a 3D, and we would like to see like the part of the water that they flow in our university that we also apply for. But actually in the world have about the security also, and also gas mapping, and about the environmental analysis. Of course, in our field, like in traffic, we also have the drone applied for, such as we use the drone for traffic monitoring, and we use the drone for data collecting. After that, we process for analysis. And the last part, recently they come with the crash investigation or accident investigation, which I would like to talk after. So to do that one, we have a processing to do about the data collection. The first thing we have to plan for our flight. We need a pattern to fly, right? We may fly like a route. We plan for a route to fly the drone. And the second one, we need to capture all of the photo that we need to collect. And the third one, we fly drone around the object. We not fly only from the top, but we fly 360 degrees from our object. Or we can use the alternative of the technology such as the 360 camera to check off our object, or LiDAR to make a sensor to our object also. And finally, we transforming those of the photo by using image processing to get a 3D or to get like a simulation that we would like to have for. And this is the actual project that I'm trying to do and using for the drone. We're flying the drone above the roundabout in front of our university. We have the problem here that you can see from the picture that we have a roundabout and then we have a truck approach zone that the driver should not be drive into the zone, and we have a lane marking that people did not following by the appropriate one, right there. So we would like to investigate how these driving behavior affect on the safety, right? If the driver did not understand how to drive into the roundabout, they may cause to the conflict in roundabout. So we would like to count, or we would like to see how the factor that they will drive into the risk, right here. And we also track on the okay, let's continue for the thing that we try to do in the future. We think about that after the accident happened. Normally we did not have much time, and especially in the peak morning or peak evening. So the traditional way that we use the people to collect the data to take a picture, right? We did not get a lot of the frame until the time condition. So if we use drone in this situation to collect, we just use like not much of the minute that we can fly the drone and then get the picture around the traffic scene right here. And we also can, after we got all of the picture that we take post of the accident, then we can use a lot of the software such as Pic4D or SkyDroid Autonomy and SkyDroid 3D scan to simulate like the traffic scene. Actually, the right one picture is the actual one that we take by the camera, but the left picture is the 3D simulation thing that we can get from a lot of frame of the picture. So why we have to list this one important? In Thailand, we actually have 3 sources to know about the traffic accident, but actually we know only the number, only the type of the car that have accident, but we did not know the traffic scene or the traffic collision diagram right here. So, and the people who collect the data, sometimes they collect by the paper in the papers, and we did not have like the big data in the central of the system. So I think if we apply for this one, we can have solved this problem that we can input the picture of this one and collect the traffic scene collision diagram to the central of the data. Okay, this is our reference that I find from. So thank you for the attention. So if you have any question, you can ask. Yes, please.
Thank you so much for your presentation, and I think it's very applicable in accident detection. I have 2 questions. The first question is regarding the trouble of battery. The battery, for instance, we have to observe the intersection in 24 hours, for example, in Vietnam. How about the battery, maybe 15 minutes, 30 minutes? How about we overcome this trouble?
Well, we actually, about the battery, is still concerned of that one, but maximum, recently we can have 1 hour. So we have to plan that we need to have some spare one.
Okay.
After you have less the battery of the first one, you can have the spare one.
So you have to prepare.
Yes, we usually
to prepare,
prepare
for example, different drones to to continuously
Yes.
observe. And the second question is regarding the slide number 8. The slide number 8. About the detections of different vehicles, because in the mixed traffic flow, there's combined of motorcycles, cars, truck, and in the slide number 8, you have how to categorize different of vehicles, especially in the case of Thailand, Vietnam, motorcycle is very, very small.
Yes.
If we observe it like this, yes, this is a mixed traffic. How you can categorize the different type of vehicles, especially motorcycle?
So actually, we can like categorize by training the model. We have used YOLO 5 in here. So when we train, we need to give a lot of the picture that tell the program that this is the motorcycle and this is the car. So we train a lot of 1,000 of the picture to let them capture.
Based on the big data of this picture, because as you can see, that motorcycle is like a dot in
yes,
this picture.
Very small,
very
like
typical.
Yeah.
Okay.
The size of the vehicle and the color of the vehicle also like obstacle of the model. So we need to train a lot. The red color, the black color, the white color, and the size, the pattern of the vehicle also need to train.
How many % of reliability of categorize?
Right now we got
80%.
80%. Yes, right now we got 80%.
Fine.
But motorcycle trial, we got motorcycle for like 70% actually.
Okay.
Yes.
And also in the dark. The dark.
We did not train for another thing. We train only vehicle. Yes. Thank you so
very
much.
Thank you.
Thank you very much, Atrans Ratanaporn. I'd like to move on to start the session 2.1 if you are ready.
Okay, so in this session, which is session 2.1, we have 4 presenters, and the 4 presenters come from Japan, Thailand, and also Philippines. So I would like to invite the first presenter, Miss Rika Kakishima from Japan. The topic is analysis of impact of spreading COVID-19 infection on usage behavior of immerse for food.
I'm Rika Kakishima. I'm from Nihon University. Today I'm going to present about my research analysis of impact of spreading COVID-19 infections on usage behavior of e-commerce for food. The background, due to the spread of COVID-19 infection, behavior restrictions have been issued in Japan. The time spent at home increased because of the implementation of telework and refraining from going out. These have led to an increase in purchasing usage of e-commerce for food. In the objective, in this study, I conducted a questionnaire survey on the use of e-commerce for food. In order to understand the relationship between the frequency of food delivery uses and the number of teleworking per month, this study clarified the impact of COVID-19 intention on the use of e-commerce for food. In the literature review, Kawasaki et al. They conducted a questionnaire survey to understand the psychological intentions and the reasons for Japanese consumers toward EC before and after the outbreak of COVID-19. Ban et al. They conducted a questionnaire survey to understand the changes in purchasing behavior that occurred when COVID-19 spread in Vietnam and the degree of impact of COVID-19. These studies haven't clarified the category of e-commerce for food, and sales form of e-commerce for food, and purchasing awareness after occurrence of COVID-19. Therefore, in my study, I focused on the three categories of e-commerce for food: store delivery and ingredient delivery and food delivery. This is the outline of the questionnaire survey. In the survey, 147 samples were collected. I conducted a survey people who live in Tokyo metropolitan area which are strongly affected by COVID-19, such as state of emergency and restaurant closures. For the target period, I focused on 3 periods. The first period is before COVID-19 outbreak. For the second time period is increasing COVID-19 infection, and the third time period is decreasing COVID-19 infections. As a result, Figure 5 shows the changes in frequency of food delivery usage. From T1 to T2, the number of people who didn't use food delivery was decreased by 28. But the number of people who used a few times was increased by 17. From T2 to T3, the number of people who didn't use it again was increased. For multiple uses, the number of people who didn't use it, the multiple uses from T2, that 5 times to 6 times and 7 times or more was increasing. For T3, 2 times and 3 times to 4 times were increasing. These results suggest that food behavior of e-commerce for food have changed since COVID-19 outbreak. This is the relationship between the frequency of food delivery uses and the number of teleworking per month. From T1 to T2, the number of people who had never used food delivery was decreased from 62 to 34. The number of people who worked at home once or more and used food delivery once or more was increased significantly from 16 to 29. This result suggests that there are strong relationships between the frequency of food delivery uses and the number of teleworking per month. So I conducted analysis to determine what factors influenced for the food delivery. I adopted a binary logistics regression analysis. Objective variable is whether or not the food delivery used. Explanatory variables are age, occupation, household income, distance from home to the station, and number of work at home. As a result, explanatory variables are only distance from home to the station remains. The result is world square is high at 2.64, but p-value is 0.10. This result shows the association with distance from home to the station is not significant. For conclusion, in this study, the use of food delivery and the spread of COVID-19 infections have a high relativity. It is clarified that there is impact of spreading COVID-19 infection on usage behavior of e-commerce for food. The second, significance of relationship between the use of food delivery and these factors was low. For future studies, it is necessary to clarify which factors increased food delivery. Also, it is necessary to compare with other e-commerce for food and continue this survey using data on several infection status. Thank you for your attention.
Thank you for Ms. Kakishima presentation. Okay, I would like to invite for the question from the audience. I think we meet with this situation in everywhere, like about the COVID-19. And I think in like overall, every country have increased for the food delivery, right? So I have just a little bit question about the number of the collection data that you collect. How many, like, how do you set the number of the people that you would like to collect for? Actually, I see 62, right?
147 samples.
147. Okay. Do you have any like methodology to classify that this one is the suitable number to collect?
Okay. I collected 147 samples for using only Google Form for online because we couldn't go to school or outside. But actually, these samples have bias because all of the samples are students or all of the samples are women. So next study I have to get another sample, not biased.
I see. And how about after you know that is it increase or is it decrease? Do you have any plan or the policy to do about this thing? Like after you know what you will use for this data that you have.
It means what kind of delivery?
Yes, after you know that the delivery food have more amount.
Yes, I have three categories in this research. The first is store delivery, like which restaurant own delivery that themselves. Restaurant deliver the people who worked in restaurant. And next is ingredient delivery, which people order in online, and in the house, the people deliver the ingredients in the house. And the third is food delivery, like Uber Eats or Grab. The result, food delivery is the most influenced delivery.
Oh, okay. Okay, thank you. Any question more? Okay, then thank you for the presentation.
Thank you.
Next, we will move to the second presenter, Mr. Titat Prompadit, that he will talk about the solving static bike rebalancing problem by using Lagrangian relaxation as stop searching criteria.
So, my name is Titat Prompadit. My presentation topic is about solving static bike rebalancing problem by using Lagrangian relaxation as a stop searching criteria for maintain a bike sharing system. So my agenda comprises of 5 parts. The first is introduction, which will provide you a comprehension of the bike sharing system. The second is motivation, and the third, methodologies, fourth, results, and finally, conclusion and discussion. My introduction is about what is bike sharing. Bike sharing is a self-service bike rental business. So due to the urban development and climate change, many countries around the world start their bike sharing project. They start to adopt it. And a common problem in the bike sharing is the demand of the bike, and the number of bikes at each station is not balanced. So we need to have an operation to rebalancing it. So my motivation is come from the formulation, mathematical formulation from Mr. Daniel Shumla. They formulate a mathematical problem that give a solution to route and rebalancing and repositioning byte. And the mathematical formulation is formulated as a mixed integer programming. The objective function is to minimize the total distance, and the constraint comprises of 4 parts. The first is conservation of node constraint. The second is the on-revolute constraint, and the third is subtour elimination constraint, and the fourth is capacity constraint. The last two constraints are generated from separation problem which generate by on the fly of the branch and cut algorithm. And the second motivation is about Lagrangian relaxation proposed by Marshall Fisher, which provide Lagrangian relaxation to give a lower bound for a branch and bound algorithm. The lower bound is utilized to find another way to find a feasible solution. And this is my methodology. The first is about the problem setting. These are the example of the byte-sharing network, which comprise of the depot vertice and station vertice. The depot vertice is about the starting point and ending point of the vehicle, and the station vertice is the services, a byte service station, and each node have a notation about the two variables, which are the number of bytes at the current situation, and the Q variable is about the number that we have. We want the byte to be this number. My purpose in the research paper is to apply the Lagrangian relaxation to the dynamic Schindler model, which we relax the last two constraints that generated by a separation problem and move the constraint to the objective function. And the right side is called the Lagrangian dual problem that we have to solve and provide a lower bound for our proposed method. These are the pseudocode of my proposed method. Inside the box is a method that we added to the branch and cut algorithm. The Lagrangian will be actuated when a feasible solution is found, and the stop searching criteria is about the current solution is more than Lagrangian dual solution, but not over 10%. And if the program found that a solution meet the criteria, stop will be stopped. Our methodology is implemented by Python and run on Google Colab Both. And we compare two algorithms, which is original algorithm, which are the branch and cut algorithm, and branch and cut with Lagrangian dual solution. So these are the result table, which are the four variables, which are the instant name and the vehicle slot capacity, stations capacity, and the number of stations. And the result is two variables, which are the base integer solution. Lower is better, and the compute time, lower is better again. So from the result, my proposed method is suited for by sharing with network more than 50 station and low vehicle capacity. And when the solution, and the second conclusion is the solution space of feasible solution is small, there is a possible that given solution is a good quality. And the terminating branch and cut algorithm by optimality gap is rarely happen in our experiment, which is a conventional method. And the low computational time should be researched more on a dynamic type problem, which is a real world problem right now. Thank you for your attention. Thank you.
Thank you for your presentation. Right now we would like to invite for the question. Quite difficult when we see the formulation, right? The method that you use is the bunch and cut, right? And bunch and cut is not global optimization, right? Is it local optimization? Do you have any reason why you pick this method?
So I think that the bunch and cut is take a lot of time to compute the feasible solution. So I want some criteria that can stop this searching and give quite a guarantee that give a good quality. But our method is not quite good enough, but it suits for more some type of problem, which are the more than 50 network size and low station capacity.
I see. Yes. And did you consider about the dynamic problem in this one, or only static?
Due to the compute time is quite low, so I think that in the future research we should apply this method for the dynamic type problem as well.
Thank you. Okay, thank you for the answer. So for next, we will move to the presentation from Mr. Shoko Seki from Nihon University, Japan, in the topic of analysis of actual condition of working environment around urban railway station in Bangkok.
I'm Shogo Saeki from Nihon University. Today I would like to talk about my research analysis of actual condition of working environment around the urban railway station in Bangkok. Background in Bangkok, 556.7 kilometers of urban railway line will be constructed to solve traffic problems. However, urban development didn't consider working environments around the urban railway stations, and it is difficult to access for station. In order to shift people to urban railway, it is necessary to assess the state of the working environment and improve it together with the expansion of railway network. Many studies have focused on the identifying the factors that influence working choice rather than evaluation the working environment itself. In this study objective, this study evaluates the working environment around the urban railway station in Bangkok and summarize the future assets of the working environment developed around the urban railway. This is a framework analysis. First, setting evaluation item, and second, setting road score and weight for scoring each road segment, and validation. Thirdly, validation of score calculation method for scores by using Google Street View. Finally, calculation of workability and comparison and discussion of results. Setting of road scores. Each road score was set for all items, which could be evaluated on a 4-level scale, with some items having a positive impact and others having a negative impact. For example, separation of pedestrian space and pedestrian and vehicle space. If no separation of pedestrian and vehicle, road score is a negative impact. If sidewalk is prepared, road score is positive impact. The item for evaluation of workability was set with 3 stages. So, upper, middle, lower. The weight of each item was calculated from the HP questionnaire result based on the response of several experts. In this study, 3 3 Japanese and 4 Thai answered this questionnaire. The working score for each road segment was calculated based on the multiplying road square and weight, and calculate workability score was standardized and compared. In this study, select 24 stations for 24 stations, MRT blue line, purple line, and BTS complete line, sun line, ARL, and SRT dark red line. Result of estimation of workability. Workability score will be low on road segments far from the urban railway station. The main reason is that these road segments sidewalk is not constructed or narrowed by obstacles. Results of estimation surface area. We estimate the surface area. The working environment is undesirable on main road segments, which is the exception of 5 minutes surface area. Averages workability, urban and suburban. In urban area within a 10-kilometer radius, sidewalks are being developed, and suburban stations tend to have lower workability score than urban stations within a 10-kilometer radius. Conclusion, this study evaluates the workability environment on the urban railway station by using the workability index, which focuses on the physically and summarize for future development. Workability score will be low on road segments far from the urban railway station that the sidewalk is not constructed temporarily and permanent obstacles and not keep safety of electric line and maintenance force. Suburban stations tend to have lower workability score than urban railway stations within a 10-kilometer radius. This indicates the need for improving the working environment around the urban railway station and urban railway development. Thank you for your attention.
Thank you for your presentation and your works. This was really important for our working in Thailand. Okay, so I would like to invite for the question. Yes, please.
Thank you for your interesting the topic. And I saw in your presentation you mentioned about the ASP method, right? ASP methods. ASP method, analytic hierarchical, ASP method.
The method that you use, the
ASP methods, right? And you could explain more how you collect the data for the ASP method in the study. I mean for the ASP, the respondent, it's like you collect, you get the result from the people live around the sidewalk, or for any the citizen. I mean,
maybe Fukuda Sensei would like to answer or.
Thank you for question. I'm co-author of this paper, so I should be answer. Actually, we interview with not the citizen. We interview with the professionals. So specifically like engineers, Thai engineers, also some professor, also Japanese engineer. So actually, we interview only not much people, less than 10 people, but the expert. But because as you know that if we interview with the ordinary people, people cannot evaluate actually. So we would like to analyze the structure of the people, how to evaluate those problems, the engineer, specialist.
Yeah. Okay.
So we interview with a specialist.
Okay, thank you so much.
Thank you. Let's say how many of the experts that we have collected?
I remember around 7 or something like this. Yeah, I think that is a common. I think in the case of HP, not necessary to interview many people.
Yes.
No meaning.
Thank you so much. Okay, any question more? Okay, thank you for your nice presentation. So for next, I would like to invite the last presenter in our session. Sorry, your name is so difficult. Eileen. Okay, from Philippines, like in the topic of an equitable transit-friendly system, a literature review. Yes.
Good afternoon. My paper titled An Equitable Transit-Friendly System, a Literature Review. So significant attention has been paid to the transportation infrastructure challenges throughout the last decades. Urbanizations and elderly populations has become a significant issue in the global cities. Several studies assess transportation networks to identify gaps or appropriate things, focusing on equity principle or disadvantaged people. Evaluation method includes defining transit service levels to assess disadvantaged people access to public transportation projects. The benefits of the transportation system can perhaps be understood through the concept of accessibility and mobility. As we all know, accessibility is defined as the number of potential opportunities for interactions and focuses on importance of relating desired destination, such as shopping, school, or work. Such solutions do not always necessitate changes to the transportation system. In some circumstances, accessibility can be improved more effectively by reorganizing the distribution of accessibility in the area and time. Better transportation accessibility was associated with increased mobility and social participation, and hence more precise sense of quality of life. This article aims to combine current literature and understanding of transit-friendly system concerning the social exclusion and transportation, and raise policymakers' awareness of equity issues. For the methodology, I use this corpus to gather studies about interest and provide a comprehensive list of articles. Boolean syntax, a search that allows users to combine keywords with operators like and, not, or to further generate more accurate results. From the database of the Scopus, I type transportation equity or transport equity or equitable transport. The total number of relevant papers to database searchings is 333 articles. By refining the Boolean operators, using the keywords transportation infrastructure and transportation system, the number of paper excluded is 292. Record screen by title, abstract, introduction, and conclusions, the number of paper is 41, and the excluded is 7. Using the full text obtained and reviewed for eligibility, the total number is 34. So using the latent direct allocation, topic modeling has proven to be a practical approach to the exploratory analysis of many papers. Topic modeling is a method that models the search text as a collection of subjects and each subject as a collection of terms. Defined word sets represents the underlying themes that can be merged to characterize each text in a corpus. So latent direct allocation is referred to as a topic model. For topic 1, The primarily focuses on the study of disadvantaged groups' mobility in public transportations. For topic 2, focuses on the social equity and transportation accessibility. For topic 3, focuses on the transportation system. And for topic 4, is on creating a transit-friendly system. Most publications are driven by the idea that, with the help of topic modeling, it's now possible to conduct an analysis on a sizable body of text that previously would not been feasible due to the time and effort required. Topic modeling can help you understand some of the main ideas in a text, but it cannot tell you everything you need to know about what it means. So for the discussion, this is a brief discussion. Number 1, exploring disadvantaged groups' mobility. Mobility contributes significantly to social inclusion and quality of life. Wak and Kugamay, for example, highlighted physical mobility as a fundamental factor in social and economic inequity. For topic 2, the social equity and transportation accessibility, as we all know, equity is typically defined as fairness in the distribution of advantages and liabilities of transportation systems across people or group in society. Transportation disadvantages and travel time-based opportunity in accessibility are multifaceted and play critical roles in transportation equity. For topic 3, transportation system, a fundamental principles of transportation systems analysis is that service demand is related to service quality. These service quality features are volume dependent. Infrastructure for transportation has significant impact on both social and economic development. For topic 4, creating transit-friendly system, bus transportation and metro rail are the two primary components of public transit or public transportation. These two major transportation systems are indispensable in enabling public transportations, and both systems are the people's essential part of their travel. Dockless bike share have the potential to replace traditional dock-based methods, mainly because they provide more flexibility for bike returns. Protecting sites with vital transportation infrastructure extend beyond the immediate vicinity in the protection. For the challenges and research gaps, number 1, the limitation of the data of participants. Moreover, inappropriate representations of the demographics, including disparity in the gender representation, location, language barrier, and behavior of the participants can influence the results. Also, the time parameters and government influence can modify the results. For the conclusions, public transportation is a crucial component of how people get around. At the community level, the effects on mobility and unevenly dispersed due to the complexity and dynamism of the transportation system. Use of driving automation systems as one of the most anticipated development in terms of transit-friendly system. Again, good afternoon and kapunka.
Thank you for a nice presentation. So we would like to invite for the question from audience about the equality, right? Yes. Okay. So after you review from all, do you have any idea that how you will develop in your country or in your experience about this?
Actually, this literature review is part of my dissertation study. So this is the initial part of my dissertation, which is related to the public transportation system. So I want to know an equitable transit system to apply in our country.
So can you share from your experience that you have met about inequality in your country?
One of my study is focused on the urban and rural. So I need to know what are the difference in urban and rural areas.
Okay. Thank you so much. So actually this time will be have for coffee break. Everyone will be happy from now, right? Coffee break from actually 10 minutes only. And for next lesson will be run by Associate Professor Dr. Paramet Lonchep after we have a coffee break.
Yes, อาจารย์
Ratanaporn, please wait for a moment. May I invite our honorable advisor once again to present a token of appreciation to Assistant Professor Dr. Ratanaporn, please. Thank you very much for the wonderful sharing the session. So next will be session 2.2, but before that we're going to have the coffee break. Make sure that you have 10 minutes coffee breaks. Okay, so, please bear with us. We have another 2 more sessions. Please be note that she will be coming back here at what time? What time? 4:25, something? Okay, please be back by 4:25. We consumed a lot of time today. Hopefully you will be okay after the session 2.2. Okay. Have a good rest. 10 minutes break. 10 minutes breaks. Okay, I'm gonna coffee break provide to you outside of the meeting rooms. Yes.
สวัสดีครับ Good evening everyone, ladies and gentlemen. Welcome back to the Atrans Young Research Forum AYRF 2022. In this session, my name is Paramet Leothep from Prince of Songkhla University. It's my honor to be the chair of this session. And in this session, we have 4 presenters from 4 different topics. The 2 presenters will be on site here, and the other 2 presenters will be present online via the Zoom system. Okay, I think everyone could you may bring your coffee break, come here, and then we can enjoy. Yes. May I check? Okay, without further delays, may I invite the first presenter, Miss Hu Jing Wang, right? Yes, from the University of Transport and Communication, Vietnam, to present the effect of alternative mobility modes and health awareness on mode choice in Vietnamese cities. Okay, the floor is yours. Please, if you're ready, please welcome her. Please give her.
Good afternoon, everyone. My name is Vũ Thị Hường, and I am from University of Transport and Communication in Vietnam. Today, I would like to present the topic effect of alternative mobility model and healthy awareness on model choice in Vietnamese city. The presentation consists for past introduction, method and survey, resource, the question and constantly. You can see that mobile school in popular in everywhere in Asia, in Vietnam. Although aptly on Solar have tried to explore the travel behavior or motorcyclists. This Atrans is being fair on the impact of health impact. That reason prompted me to study the influence of health awareness on model choice in the education study in Hanoi. In this style, we develop a multimodal logic model express to influence of 6 factors. The traction of the model can be performed by this fast design. This is the model use both qualitative and quantitative variable. Some group or variable have a description inherited from free-out student study. Behind the study on the pros, a new group of variable, the value have a wasn't with the description. A questionable survey a construction from April 1 to 50, 2021. Commuters who travel by motorcycle, bicycle, and private car were the target popular. This shows that factors belonging to the group, the social, local, characteristics have a great influence on the choice between car and motorbike, but do not affect the choice between bus and motorbike. Chief characteristics affect bicycle and bus selection behavior on the basis of mobile car. The high characteristics were equally influenced by the group that selected individual car and bus on the basis of mobile score. Cognitive and active groups have an effect on the drive behavior. Your groups have the list positive influence car and bus choice, relevant impact on bicycle choice in show that when health wasn't is higher, use win tend to choice car and give on to worse vehicle. UMNL model we established the relationship between vehicle more choice and able the alternative transport model and sportive. When implementing the policy of banning motorbike, private car and public transport and will be conscious choice of people. Women will prefer on promoting the advantage of that means first. Therefore, on the government, so by Atrans to policy. This is my presentation. Thanks for listening.
Thank you very much for your interesting topic. Is there any comments or questions from the floor, please? Could you please go to the slide number 7? Please show slide number 7. Yeah, in this table. Could you please explain why the coefficient of the health awareness, right? For the case of the private car, yes, in this one. Could you please explain why this coefficient for the case of the bus, why it's higher than the passenger car? Yeah, please. Yeah, you see this one, right? The coefficient. Yeah. Is there any reason behind this one, please?
Khi mà em chạy cái mô hình ra thì em thấy là đây là cái kết quả dựa vào cái số liệu mà em đi khảo sát thực tế. Và khi mà cái hệ số nó có sự khác biệt, trong đó thì sự hấp dẫn của cái nhận thức về sức khỏe của những người sử dụng ô tô mà cao thì họ sẽ có xu hướng lựa chọn ô tô con thay cho xe máy nhiều hơn so với lại thì cái hệ số sử dụng của xe buýt thì theo như cái kết quả này chạy ra thì có thể thấy là những người sử dụng xe buýt họ có nhận thức về tầm quan trọng của việc lựa chọn phương tiện đến sức khỏe của mình cao hơn so với những người mà họ đang sử dụng ô tô.
I'd like to translate. Based on her explanation, the coefficient of the bus is higher than a private car, possibly because the awareness of the bus users on the health impact is higher.
And also the quality of the bus is worse than the quality of the car, I mean the air pollution.
Có phải là chất lượng của xe buýt cao hơn là của ô tô hay không?
Sự hấp dẫn của phương tiện xe buýt liên quan đến cái người sử dụng thì người ta đánh giá cao nhất ở cái mức độ là nhận thức về mặt sức khỏe. Còn lại đối với lại người sử dụng ô tô thì nó sẽ có nhiều các cái yếu tố khác hấp dẫn hơn cái vấn đề là cải thiện về mặt sức khỏe của cái người sử dụng.
The bus user they perceive the health impact when using the bus is much better than the car users. Maybe because the car they have more attributes that might affect on their health.
Thank you very much for your answer. Is there furthermore comments or questions? Okay. Okay, thank you very much. Thank you very much. Okay, for the next presenter, is on the online, right? He's on the Zoom. The next presenter is Mr. Sethawut Lab Visutti Sarod, if I wrong pronounce, so sorry. His paper is about development of the autonomous delivery service prototype in Chulalongkorn University. So, if you are ready, so please.
Yeah. Thank you very much. I would like to share my slide, please.
Yeah, please share.
Yeah, I cannot share. It said host disabled participant screen sharing.
Okay, please wait a moment.
Yeah.
Please wait a second.
Okay.
Okay.
Okay, I think it. Okay now. Good afternoon, Mr. Chairman and all of the Atrans participants. Today I would like to share to you about the development of autonomous delivery service prototype in Chulalongkorn University. I'm Sethawut Lavisuthi Sarod, a PhD candidate from Chulalongkorn University. So the motivation behind this project is that we have the collaboration with TrueRap, which is a research unit of the True Corporation, the telecom operator, and through need to prove that the concept of autonomous vehicle, especially autonomous delivery service, is feasible for their service and other business units relating to True, such as True Coffee and 7-Eleven. For the SAE standard of level of driving automation, there are 6 of automation level, 0 to 2, which is the human driver take responsibility of the vehicle, and the other one is 3 to 5, which is the autonomous software will take responsibility of the vehicle driving. So in our case, our vehicle is SAE level 3 because we have developed software to take responsibility of the vehicle control, and also the vehicle can operate in a defined area. For the autonomous control architecture, actually we can separate them into 2 types. The first one is a high-level control, which have a structure as a figure in the right. The high-level control is used for take control of the vehicle in terms of route planning and behavioral planning. The other one is the low-level control. Low-level control will control the vehicle according to the high-level control command. So in this slide, we show the software architecture of the high-level control of the autonomous software. Basically, the autonomous software can be separated into three parts. The first one is the perception layer, which will receive the raw data from the sensor and then process and send to the other layer, namely the planning layer, which it will plan the operation route as well as the driving behavior of the vehicle. The other one is the trajectory control layer, which is the layer that will take input of the final trajectory, then calculate and then send the low-level control command to the low-level control. This project, we will use the Toyota Hamo, which is the ultra small electric vehicle from the CU Toyota Hamo ride-sharing services. In order to make the vehicle drive autonomously, we have to modify the vehicle, especially in three different systems: the steering, braking, and acceleration system. The vehicle specification you can see on the right or maybe in the conference positioning. This is the system that we modify. We install DC motor for steering actuator and braking actuator. Especially the braking actuator, we also install another braking cylinder to be able to allow the vehicle can operate by the autonomous software and the human driver at the same time. So this is the speed controller of the vehicle. I cannot take into the deep detail because of the constraint of the time. I will explain to you the concept. So to control the vehicle, we have three actions to do. The first one is to apply the accelerator pedal to accelerate the vehicle. To decelerate the vehicle, we can do two things. The first one is release all the pedal, the accelerator pedal or the braking pedal as well. The vehicle will decelerate itself according to its inertia. The third one is the decelerate by the braking actuator. From the cruise control algorithm, we divided the output of the controller into three parts. The first part is the increase of the vehicle speed. That if we need vehicle to increase their speed, the accelerator pedal will be applied. The other one is if we need vehicle to decelerate, not much, just a small amount, the vehicle can be decelerated by let go of both braking and accelerator pedal. The last one is the vehicle, it needs to decelerate more, we can apply the brake. The control raw of this cruise control system view, you can see in the equation on the lower left. However, after the cruise control, the PID controller will be used to control the actuator separately, as well as the steering control as well. So in terms of the high-level control of our system, we use Autoware.ai, which is the open source software. The architecture of the Autoware AI is similar to the one that I've already told you before. However, our vehicle will use the radar sensor as well as the GPS as a main sensor for the vehicle. The radar sensor will be used in the perception method to filter the object or obstacle that separate from the ground and send it into the planning process afterward. The planning process will take into account the traffic information as well as the obstacle information, and then send the vehicle control command to the low level control. Actually, AutoWare provided actuation or low level control as well, but we use our own design. Because our vehicle is a delivery service system, so we have to install the delivery box, which is an IoT boxes. The box can connect it to the network and receive the open signal from the user and the vendor mobile application. The application we also create our own application to use with the delivery box, and as well as the car. The application can send the open signal will allow the correct customer to open the box, and also to provide the destination of the operation to the vehicle itself as well. Before we carry out the field operation test, we have to prepare two more data. The first one is the point count map, which is the map that contains the static object of the field testing field. The other one is the vector map, which is consists of the traffic information of the testing field. For the field operation test, we simulate the delivery operation by let the vehicle stop at a standby location, waiting for the order from the customer. When the customer order the product, the vehicle will travel to the pickup location with simulate the shop and or the vendor location. Then the vendor will put the goods into the vehicle and send the signal to the vehicle to operate or travel to the drop location to the customer. When the when the vehicle arrives at the drop location, the customer can use the mobile application to unlock the box and take out their goods. So I have the video for our operation, and I will explain the result during the video is playing. The mobile application, the delivery box, and also the autonomous vehicle can operate as intended. However, if we want to use the vehicle in more like a real situation, we have to carry out the extended testing and development to make sure that the vehicle have reliability to both system hardware and software. Also, the database server quite has some delay. If we can use other server that have slightly less delay, it will be more convenient for the customer. Also, now the vehicle connect to the Wi-Fi network. If we need to use this vehicle in the more public area, we can modify the vehicle to use other networks such as 5G connectivity that allow the vehicle to connect with high bandwidth and less delay to the network. I think this is all of my presentation. Please, if you have any question.
Okay, thank you very much, Mr. Sethavut. Is there any comments or question from the floor, please? Okay. Yeah, please, Sensei.
Thank you for your presentation, and also I appreciate your attempt. But anyway, many automobile companies try to make an autonomous vehicle right now. So what is the new technology or new idea on newer system? Can you understand?
Yes, actually, there are quite a lot of approach for individual system of the autonomous vehicle itself. Actually, for us For the algorithm itself, we didn't quite develop the completely new thing. We try to implement from the existing one because if you can see at the autonomous software architecture, there are quite a lot of software algorithm that need for the autonomous vehicle, and individual software need separate expertise for the autonomous vehicle as well. So for this project, I think we developed the route planning concept and the the connectivity of the vehicle to be able to use as a complete service for the delivery service. But for the future, well, or maybe for the another project, we will develop more in terms of the planning model and the driver behavior estimator model for the autonomous vehicle, but it not yet included in this project. I hopefully this answer your question.
No, I just simply ask, what is a new technology or a new idea? Only that. Because you know that there are many autonomous vehicles already, like a Honda Legend or Toyota also have a lot. So what is a new idea? What is different with those other autonomous vehicles as a research?
Like I said before, the completely new idea maybe it's not in our project, this project, because this project we focus on the design the vehicle that can implement in the operation domain design that have been provided or request for the funding companies, and prove that okay, if you have the autonomous vehicle as an autonomous vehicles delivery service, you can use them in your in their business unit as well. It's kind of like the development project, not completely research, the new algorithm project.
So implementation and demonstration.
Maybe like the local adaptation.
Okay,
right?
Thank you.
Okay, thank you very much, Mr. Sethawut. May I move to the next presentations about transportation noise investigation and modeling using multiple linear regression will be presented by Mr. Reno Enos from De La Salle University, the Philippines. So this one will be the video clip, right? Yes, okay.
Good day to everyone. I am Ronald Anos, and I shall present our paper entitled Transportation Noise Investigation and Modeling Using Multiple Linear Regression. Transportation noise derived from roadside traffic continues to be concerned in highly urbanized areas such as Metro Manila. Not only does this become a nuisance to its nearby surroundings, but frequent and excessive exposure to such noise may negatively impact human behavior and performance. According to the Centers for Disease Control and Prevention, prolonged exposure to noise above 70 decibels may result in adverse health effects such as hearing damage. In the Philippines, laws and standards on allowable noise levels are given by the defunct National Pollution Control Commission. Regardless, such laws have given little emphasis on noise that is generated from traffic streams. Furthermore, there are no available transportation noise models that can be applied in the evaluation of future projects and developments. Despite having multiple models available internationally, these cannot be easily applied to the Philippine setting due to varying local conditions. Thus, this study aims to investigate sound pressure levels derived from vehicular traffic along major thoroughfares within Metro Manila. Specifically, the objectives are to measure the level of transportation noise along 9 selected roads in terms of the equivalent continuous sound pressure level, to compare the measured noise with existing standards on allowable noise levels, to generate a multiple linear regression model that relates noise levels with contributing road and traffic characteristics, and lastly, to verify the accuracy of the generated model. Data collection was performed in January this year during the off-peak hours of 9 a.m. to 3 p.m. due to mobility limitations in light of the COVID-19 pandemic. Study sites along the 9 roads were selected based on a predefined criteria. This included at-grade road sections and areas with no excessive pedestrian traffic and external sources of noise such as nearby factories and active construction. An RS Pro sound level meter with data logger was used to collect sound pressure levels along the area for a 15-minute recording period. The A-frequency weighting and fast response time was employed to approximate human hearing. This was performed for 5 intervals for each location, resulting in a total of 45 average sound pressure levels. Additional road and traffic parameters were also collected from field data and video recordings. These included the road classification, lane count, presence of barriers, road surface, distance from upstream and downstream intersections, average vehicle speed, the total vehicle count per 15 minutes, and the percentage of light, medium, and heavy vehicles in the traffic stream. Data processing was performed using the SPSS software, wherein 75% of the dataset was used for model generation, while the remaining 25% was used for model validation. The resulting average LEQ across all locations was found to be 70.806 decibels. Based on the performed one-tailed key test, this value does not significantly exceed the 70 decibel threshold of the CDC, as well as the 75 decibel standard from the NPCC for a typical commercial road with more than 4 lanes. However, some roads had significantly higher average noise levels, with Mindanao Avenue yielding the highest value of about 76 decibels. This road also had a significantly high vehicle count and the highest percentage of trucks and other heavy vehicles compared to the other roads. Independent samples, t-tests, were also conducted to determine whether certain variables yielded a statistically significant difference in the measured sound pressure level. Results showed a significant difference in mean LEQ values depending on the presence of road barriers, wherein divided roads yielded a higher mean compared to undivided roads. However, no significant difference in LEQ values was found with respect to the road surface, whether concrete or asphalt. Lastly, t-tests on the 3 DPWH road classifications showed no significant difference in LEQ values between primary and secondary roads. Moreover, both roads each differed significantly from the mean LEQ values of tertiary roads. This slide shows the general MLR model using 75% of the dataset. As shown, the equivalent sound pressure level along a given road segment is dependent on the logarithm of the vehicle volume for 15 minutes, the percentage of heavy vehicles, and the number of lanes. All of these variables are shown to be statistically significant and have no severe correlation with each other. The intercept of the model, with a value of 51.13, will correspond to the ambient noise levels when no traffic is present. This is comparable to the lowest sound levels recorded along tertiary roads. The model yielded a satisfactory R-squared of 0.876 and a standard error of 1.235. Other regression models were also generated depending on different categories as shown in the table, all of which had similar significant independent variables except for the tertiary roads model. The high intercept of this model may also suggest that the noise levels along tertiary roads are heavily affected by other factors such as pedestrian volumes. Despite also yielding fairly high R-squared values, these categorical models may not be highly accurate nor representative due to a limited dataset. 25% of the total data was then used for cross-validation of the general MLR model. The calculated root mean square error and average percent error would indicate a good prediction capability. The graph shows a plot between the predicted and actual measured LEQ values for each data point. The results from simple regression also yielded a satisfactory R-squared of about 0.85. In conclusion, transportation noise is an essential concern, especially in urban areas. Results from the MLR model shows that the noise levels are highly dependent on the total vehicle volume and percentage of heavy vehicles. This could translate into policies such as road restrictions on trucks and similar vehicles, especially near noise-sensitive areas such as schools and hospitals. However, much can still be improved on the study by expanding the dataset and considering temporal variations of traffic. Lastly, it should also be noted that addressing transportation noise may rely on a combination of programs and considers other factors as well. That is all for my presentation. Thank you for listening.
Okay, thank you very much. Thank you very much for the presentation. And okay, you all right? Okay, is there any comments or question from the floor, please? Okay, no. Not yet. Okay. Mr. Arnold, when I consider from your model MRL model, I saw your three significant factors: the number of vehicles, the percentage of heavy vehicles, and number of lanes. Right?
Yes.
When I consider the size, I mean the size of the coefficient of the number of lanes, it show the negative impact, minus 0.77 something. Yeah, could you please explain why the higher number of lanes, it will give you lower noise level?
An, an explanation to this would be the distance of the sound level meter relative to the positions of the vehicles along the road. So if, for example, for a 6-lane road, those vehicles that pass through the innermost lanes would result in smaller LEQ values, since the SLM, the sound level meter, is located in the sidewalk on the opposite side of the road. That's why there's a negative correlation.
Is there any further questions or comments? Okay. Okay. If no, thank you very much, Mr. Arnold. Thank you. Okay.
Thank you.
May I move to the last but not least, the paper about the real-world autonomous vehicle and environment simulation in Chulalongkorn University will be presented by Mr. Silapop Bawon Rapporn, right? Yeah. So if you are ready, the floor is yours. Okay. Okay.
Hello. Okay. Thank you for giving me this opportunity to for inviting me to Atrans conference. My name is Sirapop Bawaraporn, and I'm a researcher at Smart Mobility Research Center. Today, I want to show you the interesting topic about autonomous vehicle simulation. In the recent years, the technology of self-driving is growing exponentially. But before we operate the vehicle on the road, it might be danger. Then we must have test procedure to ensure that the algorithm of self-driving is working properly. If we test the algorithm that we just developed on the main road, it may be danger to the road user and the properties. And it have a high cost and amount of time to prepare the vehicle for testing. So to solve this problem, we built the virtual environment and virtual autonomous vehicle to test for use to test the algorithm that will be used in actual car. So we call this digital twin. The test position of this research, we have a 3 stage. The first stage is we modeling a car and we create the virtual environment, and then we combine and our stuff in using color simulation, and we are using an auto-aware to control the vehicle in color simulation on autonomous mode. And then we test and evaluation the simulation. Let's talk about methodology. We divided into 3 sections of software tools. The builder is a software tool that create the virtual environment and model a car using Roadrunner and Blender, and then we simulate and generate the environment and scenarios in color simulation, and then we use the auto-aware to take control the vehicle in autonomous mode. Due to we test in the low level speed, so low speed testing, so we model car focus on the dimension of the vehicle, and we not consider in dynamic model of the car. And to create the virtual environment, we're using OpenStreetMap and Roadrunner to and then generate an environment in color simulation. The body of this research is on Chulalongkorn University. Before we test and evaluation, we need to integrate the color simulation and auto-aware. The color simulation, we can generate the environment and the vehicle that attach all the sensor needed for autonomous car, and we use the auto-aware. Auto-aware is an open source software that for autonomous driving, and they have many algorithms to use. But in this research, we focus on the 3 algorithms, which are localization, motion planning, and path following. Localization is an algorithm that to locate the position, vehicle position in the map. The map that we use is a point cloud map that we get it from LiDAR sensor. And then motion planning, we plan the route of the vehicle, and the vehicle we followed the route by using the path following. The control system of the real world and virtual world vehicle, we can see that we have a 2 diagram. As you can see, we use the auto-aware to take the control in self-driving in the real world and the virtual world. And then the auto-aware will send the data to the low-level control, just like position, speed, and yaw angle. This is an overview of color and auto-aware interface. You can see that the color display in the top left and auto-aware in the bottom left, and loss visualization on the right. The loss visualization is an tool that show the graphical interaction between the loss and the sensor in the vehicle. To test and to verify the simulation, we need to compare the behavior of autonomous vehicle in the real world and the virtual world along the predefined route using path following at a moderate speed. And we compare the discrepancy between the real world and the virtual world. The test position, we have 3 sections. The first one is we manually control the vehicle in the real world that we use Toyota Hamo, and then we collect all the data through auto-aware, and then we will get the data set consists of coordinate of the car, speed, and yaw angle. Can you see? You will see in the right corner. And then we use this data and send to the autonomous mode in the real world and the virtual world. And then we will get the path of both worlds. Okay, this is an example video that why the virtual vehicle is operating in autonomous mode. Okay, the result of this experiment, we compare the real world waypoint that is input, and output is a virtual world path and a real world path. As you can see, the output is the same 10y as the input, and you can see that the real world path in the green line is was offset from real world waypoint. Maximum error distance is 0.4 meters. And the conclusion is the behavior of simulated car and actual vehicle is follow the waypoint that we have given. And the response of simulated car is nearly the same as we order. And the part of actual vehicle that operates in the autonomous mode is maximum offset is 0.4 meters because low-level control was deterred from actual environments such as road guidability, road surface, and sensors. Thank you for attention.
Okay, thank you very much. Is there any comments or question from the floor? Yeah, please.
I would like to have one question. In the environment simulation, did you consider the in-physical environment, for example, the lighting, smoke, heavy rain? Did you consider it? And if yes, how is different between the real world and the virtual world behavior? Thank you.
The first question is we focus only on the behavior of vehicle.
Physical? Physical only?
Yeah, physical.
Physical only,
yes.
okay.
And the second question is why the how different between the real world and virtual world.
So do you think about the further step considering the in-physical, the heavy rain, the lighting, the darkness? Do you consider it?
Yes, we just focus, we scope the research in daylight, and we in the further project we will test in the night or
okay.
during the rainy day, like yeah.
Maybe what is the main difficulties when you want to simulate the environment in terms of in-physical? What is the most difficulties?
The most difficult is we you can see that we use many programs to simulate the environment and vehicle, and we need to integrate the algorithm of autonomous vehicle to use in our virtual autonomous car, and that is so hard.
Thank you, thank you.
Okay, thank you very much. Thank you very much. Okay, okay. May I conclude this? Yeah, thank you very much for your excellent presentations.
Thank you.
May I conclude this session? We have 4 presenters from 4 different interesting and challenging topics, and due to the time limitation, so I would like to move to the next session. We will share it by Dr. Putipong. Yeah, please.
Thank you very much, Ajahn Parameet. So before that, may I invite our honorable advisor once again to present a token of appreciation to Ajahn Parameet, please. คุณค่ะ Thank you very much. And next, may I invite Dr. Puttipong. Dr. Puttipong, Turakasikon, Thammasat University. Okay, if you're ready, please. Since we already are behind schedule, I would very much like you to, keep time as effective as possible. Thank you very much.
Okay, welcome all participants to this session. This session has only 3 papers. One paper cannot come due to the emergency situation. So this session is about sustainability in transportation. So there will be 3 presenters. Please welcome the first one, Ms. Nguyen Huong Tan, to present the proposal on indicator and method to assess sustainable development of urban public transport in Vietnam.
Ladies and gentlemen, today I'm very happy to present my presentation in the Atrans conference. Due to healthy reasons, my colleagues from Vietnam are not here to present their presentation. So I will present on behalf of my colleagues. Yeah. We have 4 people. I have a secret that I will present 4 people consecutively in a round, or I have to 4 paper by paper. Okay. Oh yeah. Thank you. The first paper is proposal on indicators and methods to assess sustainable development of urban public transport in Vietnam. The first slide is organization of public transport system in urban area in Vietnam. As you can see, the public transport authorities manage transport service supplier, and the transport service supplier provide public bus service to passengers. The second line is factor affecting operation of public transport system. We mentioned sustainable development of public transport. Development of public transport is a transformation increasing in positive direction in the size and quality of public transport system, road networks, infrastructure, vehicles, and technologies, and executive management capacity to meet the increasing travel demand. The development process must be done on synchronously and in accordance with long-term planning and strategy. And sustainable development of public transport is continuous, stable, long-term that maximize the current travel needs without compromising the ability of future generations to meet that travel needs. And requirement of sustainable development of public transport, we mentioned 5 issues. The first is ensure economic efficiency, ensure fairness and means, ensure friendly and environmental protection appropriate master plan and policy, ensure sustainable financial result. And the indicators to assess sustainable development of urban public transport with 6 main groups. The first is economics, the second is financial, The third is social. The four is environmental, and five is institutional. Yeah, and the sixth is typical groups of criteria for the development of public transport system. We have four. We have 6 steps to assess indicators of sustainability of public transport. And this is a process to implement sustainable development indicator of public transport with four steps. Thank you for your attention.
Okay. Thank you for this paper. Are there any questions from audience? Okay. Actually, I have one. I would like to ask, which method do you use to classify the indicator into each categories? Because something quite not belong together in one category.
Yes, based on the international experience of studies in example is the study of Dr. Myler in 2014 about a list of indicators in sustainable development of public transport. I propose list of indicators in the public transport. It depends on condition of the big city in Vietnam. Yeah.
So you have something like expert, right?
Yeah.
To help sort things into the categories.
Yeah.
Okay. So any questions? Okay. So please let me move to the next one. You will be presenter again.
Yeah.
Okay.
I will present.
Yeah. The next one is about management of public transport in Haiphong City, Vietnam. A serious improvement to success is about a government problem, right? Please, floor is yours.
The next paper related to the public transport in Haiphong City is the third largest of Vietnam. The paper is management of public transport in Haiphong City, Vietnam, a serious improvement to success. If when you come to Vietnam, you can see the private vehicles are dominant in the current situation of the transport. It's a set reality. It leads to a low quality of life, and all solutions, all measures focus on to improve public transport. The current situation of public transport in Haiphong City, you can see current bus networks is incomplete, lacked areas not covered. Infrastructure and fleets do not meet the entire network. Good and affordable urban public transport requires subsidy, and with the technology and passenger information, at present only part of the fleet. The fleet is provided with GPS and automated fare collection system. Has not been set up on any routes to control tickets and revenue. We compare the public transport planning 2007 and 2018 in Haiphong. You can see the public bus transport in Haiphong is not respond to development of public transport. This is the current management model of public transport in Haiphong. You can see we have 5 levels from the city's government, the Department of Transport, Public Transport Authority, and operators and branch enterprise. We mentioned issues on management of public transport. We are six mentioned. We are six issues. First, public transport network planning. The second is fleet, infrastructure, and technology. 3, service quality of public transport. 4, operators and exploitation. 5, subsidy and financial result. And 6, is institutional framework and management model of public transport. And we mentioned that we have two serious improvement. The first is development of the PTA model. The second is management of an integrate public transport network. The third, management of infrastructure and technology. The 4, management of service quality. 5, management of subsidy and financial result. How to make a success of public transport? We are 3 issues and 5 improvement. The development of infrastructure, high quality fleet, advanced operation technologies, a good development plan, a good organization, a good management, high service quality, and wide communication. Possible revenue results for public transport to sustainable development. The first is parking fees. Fees for management and exploiting infrastructure. Fees for management subsidies. Investment on bus stops, shelters, and stations. Revenues from penalties, especially in the service contract. Thank you for your attention.
Okay. Okay, we have one presenter in a row. So do you have any question from the floor? Yes, please.
Your last slide, you mentioned about the revenue. I mean, the revenue from other sources, right? And I just want to ask if those revenues are chartered by your laws. I mean, it's eligible for your authority to collect and pull it and give it to public transport.
Yeah, I know. I mentioned the possible revenues in transport sector. The first is financial results in management of subsidy. Yeah, one. The second is the revenue in the fees of management of the contract between the city government and the enterprise. The third is, I think it's a possible revision is parking fees in around the city. Then to reinvest to infrastructure. Yeah, and I think it's an important issue that the city government has a political answer to the policy for development public transport. Yeah.
Well, I think it seems to me that when it comes to practice, the company who, I mean the bus company, they must have their own budget. But the local authority who collects some tax, some fares, they may have other priority to use rather than spending on purchasing new bus. Yeah, but anyhow, I have recommendation. Just want to ask, what is your dream of public transport in Haiphong?
Yeah.
Perhaps you may have it in your head. No need to answer, but I just want to warn you that in bringing high-tech vehicles may be not good for the community. For example, if you bring in EV buses or something like that, you're going to end up with maintenance, which you need to rely on the vendor. I mean, the local people could not fix it, you see. Not like the ordinary diesel or benzene. As well as bringing in high-tech fare collection system may not be good if the public, I mean, acceptance is low, you know. I mean, people don't know how to get on and using electric cart on a bus, something like that. So your system might fail. Okay, that's my general recommendation. Thank you.
Thank you for comment.
I think,
Yeah,
I think the policy should be included in the regulation of the city government and the Vietnam government. I think so.
I have a very short question. Does Vietnam allow 100% ownership of from outside, like company, to invest? 100% ownership of operation of buses to invest in bus? Does it allow 100%?
Sorry?
Private company.
Can you repeat?
Does Vietnam allow a foreign company 100% ownership to operate in Vietnam?
Oh, I know. It's spent on about 30 to 40%. Yeah.
Okay. So, are there any questions? Okay. Thank you for this one. And the next one is the low carbon, right?
Yeah.
Okay. The topic is about low carbon urban transport. Okay. Policy context in Vietnam and development orientation in Haiphong City. Okay, we have to skip one. Okay, so we go to the last one. All right.
Yeah.
Okay. The last one for this session is analysis of efficiency of urban public transport, a case in Haiphong.
Okay. Okay, the last papers in the study group is analysis of efficiency of urban public transport. Okay, study in Haiphong City, Vietnam. The current situation of public transport in Haiphong City, we present, and I will next slide. Efficiency of urban public transport is considered in 7 issues. The first is restrictions on use of private vehicle, benefits of reducing traffic congestion and accident, benefits of fuel cost savings, saving environmental protection task for the state, benefits of reducing vehicle emissions and noise, benefits of reducing traffic accident, efficiency on point view of operators and users. Public transport modes, where we can see that every day we we will departure to go to work, to go to school, to go home, and that destination is shared by most private vehicle, public transport, and bicycles and walkable. How much space is needed for one bus? You can see one dedicated bus lane can replace 6 or more car lanes. Yeah, you can see. So, benefits of reducing traffic accident. We consider in the current situation of traffic accident in Haiphong, total of 518 traffic accidents in the period 2013 to 2017. We can see it's approximate 35 billions based on per capita income 2,200 USD per year due to the increase of cars and motorcycles. Using the bus will be safe and reduce traffic accident. Efficient on point view of operator is I mentioned 5 issues. The first is support mechanisms and policies, support investment, support technologies, and operations and operators brand. Yes, efficient on point view of users. The first is cheaper. The second is safer. The third is more convenient. The fourth is ensure health of users. And finally is build traffic secure urban civilization. And what needs to be done to develop public transport for Haiphong? Oriented development and 5 oriented development. The first is planning for sustainable development of public transport. The second is enhancing high quality bus service. The third is improving institution and policy development. The fourth is innovation in operation technology. The five is developing high quality human resource. Thank you for your attention.
Okay, thank you. This is the last paper from this session. Do you have any question with this presenting? Okay, no. So I just have one quick question. What made you believe that when people using the motorcycle and go to bus will be safer? Because when demand for bus is increasing, it will make the same thing.
Yes, I believe that the policies of the Vietnam government to reduce the private vehicles in the period to the 2030, and we enhance the level of public transport in the urban city, in the big city in the Vietnam, and we will improve the current situation of public transport in Vietnam. Because you can see in the Vietnam, in the big city, for example, Hanoi, Ho Chi Minh City, or Da Nang or Hải Phòng, called by the name the motorcycle dependent city. Yeah, that you can see. You have to the use of private vehicle and the service quality of public transport.
Good. This is the end of the session, and thank again for the presenter for the long talk.
Thank you.
Presenting for his college. Okay, thank you for everyone.
Okay, thank you very much, Dr. Puttipong. Before following the sessions, may I again invite our honorable advisor, Mr. Silvachai, to present a token of appreciation once again, please. Thank you very much, Dr. Puttipong. This is a very short and brief session indeed. Yeah. Okay, ขอบคุณค่ะ ขอบคุณค่ะ Next, I would like to invite Assistant Professor Dr. Pong Pan Thangasem from Mahasarakam University to share the last sessions, session 3.2. In this session, there are 3 presenters making presentation in this session. I guess 2 will be presenting online, right? And 1 present on site. Yes. May I know, Mr. Anuwat? Can you raise your hand? Okay, good. So, อาจารย์เชิญค่ะ
Good evening. My name is Pongpan Thangasem. I'm from Mahasarakam University. Okay, I'm very pleased to be here. Today, we have the 3 presenters. The first, may I move to the first presenter, Mr. Saruta Chan Pasong. I'm sorry, Miss Saruta Chan Pasong will be the online. Okay.
สวัสดีค่ะ ดิฉันนะคะนางสาวสุรตาจันทร์ประสงค์ค่ะ จะมาพรีเซนต์เรื่องความต้องการทำงานที่บ้านหลังโควิด -19 ค่ะ โดยนำเสนอทั้งหมด 6 หัวข้อนะคะ ก็จะมีบทนำทฤษฎีและงานวิจัยที่เกี่ยวข้องค่ะ วิธีดำเนินการนะคะ ผลการวิเคราะห์ การอธิบายแล้วก็หัวข้อสุดท้ายก็คือสรุปและข้อเสนอแนะค่ะ มาเริ่มกันที่บทนำนะคะ หลายคนคงทราบดีนะคะว่าช่วงที่เกิดการระบาดของโรคโควิด -19 เนี่ย รัฐบาลเนี่ยมีมาตรการขอความร่วมมือให้ทุกภาคส่วนปฏิบัติงานที่บ้านนะคะเพื่อลดการแพร่เชื้อของโควิด -19 ค่ะ พอได้ลองทำงานที่บ้านแล้วเนี่ย หลายคนติดใจนะคะอยากทำงานที่บ้านต่อถึงแม้ว่าจะหมดช่วงล็อกดาวน์แล้วก็ตามค่ะ ซึ่งปัจจัยที่ส่งผลให้เกิดความตั้งใจที่จะทำงานที่บ้านต่อเนี่ยอาจจะนำไปสู่การเลือกซื้อที่พักอาศัยในอนาคตได้ เนื่องจากพฤติกรรมของคนเนี่ยเปลี่ยนไปจากเดิมค่ะ บ้านไม่ได้เป็นที่พักอาศัยเพียงอย่างเดียวอีกต่อไปค่ะ จึงเกิดเป็นข้อสงสัยว่ามีปัจจัยใดบ้างค่ะที่ส่งผลต่อความตั้งใจในการทำงานที่บ้านค่ะ และแนวโน้มที่คนอยากทำงานที่บ้านเนี่ยมากน้อยเพียงใดค่ะ การศึกษานี้นะคะมีวัตถุประสงค์เพื่อวิเคราะห์ปัจจัยที่มีผลต่อความตั้งใจในการทำงานที่บ้านค่ะ โดยคาดว่าการศึกษานี้สามารถนำไปสู่แนวคิดการพัฒนาที่อยู่อาศัยเพื่อรองรับการทำงานและการใช้ชีวิตวิถีใหม่ที่มีประสิทธิภาพต่อไปในอนาคตได้ค่ะ ทฤษฎีที่ใช้ในการศึกษานี้นะคะก็จะใช้เป็นแบบจำลองความรู้สึกส่วนตัวและบรรทัดฐานทางสังคมที่ส่งผลต่อพฤติกรรมค่ะ เป็นแบบจำลองที่อธิบายถึงความรู้สึกส่วนตัวนะคะหรือว่าที่เรียกว่า personal และบรรทัดฐานทางสังคมค่ะหรือที่เรียกว่า normative นะคะส่งผลให้เกิดความตั้งใจจะทำพฤติกรรมนั้นๆค่ะหรือว่า behavioral intention นะคะดูได้จากโมเดลด้านนี้นะคะก็จะเป็น personal normative นะคะที่ส่งผลไปถึง intention นะคะส่วนการวิเคราะห์นะคะเราจะใช้EFA, CFA แล้วก็ SEM นะคะในการวิเคราะห์ค่ะงานวิจัยที่เกี่ยวข้องนะคะฉบับแรกนะคะ COVID and Working from Home Long-Term Impacts and Psycho-Social Determinants นะคะศึกษาผลกระทบระยะยาวจากการแพร่ระบาดของโรคโควิด -19 ในด้านการ Work from Home ค่ะและปัจจัยที่ส่งผลให้เกิดความตั้งใจที่จะ Work from Home หลังโควิดค่ะใช้แบบจำลอง TPB นะคะหรือว่า Theory of Planned Behavior นะคะเราวิเคราะห์ด้วย SEM ค่ะโดยพบว่านะคะช่วงล็อกดาวน์คน Work from Home เพิ่มขึ้น 310% ค่ะหลังโควิด -19 คลี่คลายเนี่ยคนอยาก Work from Home เพิ่มขึ้น 75% นะคะเทียบจากก่อนโควิด -19 ระบาดค่ะปัจจัยที่ส่งผลให้เกิดความตั้งใจที่จะ Work from Home นะคะก็คือ PBC ค่ะหรือ perceived behavioral control นะคะและ SN ค่ะหรือ subjective norm ค่ะฉบับต่อมานะคะ Real estate market responses to the COVID-19 crisis which prospects for the metropolitan area of Naples, Italy นะคะวิเคราะห์แนวโน้มตลาดอสังหาริมทรัพย์หลังเริ่มมีการระบาดของโรคโควิด -19 ในเมืองเนเปิลส์ประเทศอิตาลีค่ะวิเคราะห์ด้วย GIS software นะคะพบว่าผู้อยู่อาศัยต้องการมีพื้นที่ใหม่ในบ้านนะคะ 53%เนี่ยต้องการให้มีพื้นที่เปิดค่ะ 33.1% ต้องการให้มีพื้นที่สำหรับทำกิจกรรมยามว่างค่ะและ 23.4% ต้องการให้มีพื้นที่ทำงานหรือเรียนนะคะฉบับต่อมาค่ะ How the first wave of COVID-19 in Switzerland affected residential preferences นะคะสำรวจผลกระทบของการเลือกที่อยู่อาศัยจากการเกิดโควิดรอบแรกค่ะวิเคราะห์ด้วย regression model นะคะพบว่า 40% ของผู้ตอบแบบสอบถามเห็นว่าความต้องการที่อยู่อาศัยในช่วงก่อนและหลังโควิด -19 เนี่ยไม่แตกต่างกันค่ะเพราะโควิด -19 ระลอกแรกระบาดไม่นานนะคะและคาดว่าสถานการณ์จะกลับมาปกติโดยเร็วค่ะฉบับสุดท้ายนะคะ Do changes in residential location lead to changes in travel attitudes a structural equation modeling approach วิเคราะห์ว่าการย้ายที่อยู่ส่งผลต่อทัศนคติในการเดินทางอย่างไรค่ะและรวมไปถึงการเปลี่ยนแปลงของความถี่ในการเดินทางนั้นๆทั้งทางตรงและทางอ้อมอย่างไรบ้างนะคะพบว่านะคะการย้ายที่อยู่อาศัยส่งผลให้ทัศนคติในการเดินทางเปลี่ยนแปลงไปค่ะโดยคนส่วนใหญ่เนี่ยย้ายไปในพื้นที่ที่มีความเป็นเมืองมากขึ้นค่ะทำให้ใช้รถส่วนตัวน้อยลงค่ะวิธีการดำเนินการนะคะขั้นแรกนะคะก็ระบุความเป็นมาและวัตถุประสงค์นะคะจากนั้นทำการศึกษาทฤษฎีและงานวิจัยที่เกี่ยวข้องค่ะออกแบบสอบถามนะคะทำ survey แล้วก็มีการปรับปรุงแบบสอบถามค่ะแล้วก็เก็บข้อมูลจริงนะคะจากนั้นนำไปวิเคราะห์ EFA CFA แล้วก็ SEM นะคะแล้วก็นำผลที่ได้เนี่ยมาวิเคราะห์ค่ะและขั้นตอนสุดท้ายก็สรุปผลค่ะการเลือกกลุ่มตัวอย่างการศึกษานี้ใช้ cluster sampling นะคะในการสุ่มนะคะเนื่องจากว่าต้องการเก็บข้อมูลจากผู้ที่ทำงานในกรุงเทพและปริมณฑลค่ะจึงทำการสุ่มตัวอย่างประชากรจากพื้นที่นั้นๆนะคะตามจำนวนที่ต้องการค่ะบริเวณที่เก็บข้อมูลนะคะใกล้กับสถานีรถไฟฟ้าหมอชิตอารีช่องนนทรีพระราม 9แล้วก็อโศกค่ะส่วนจำนวนกลุ่มตัวอย่างนะคะอิงจากสัดส่วนของตัวแปรค่ะขั้นต่ำก็คือ5เท่าของตัวแปรนะคะการศึกษานี้มี10ตัวแปรค่ะขั้นต่ำก็คือ100ชุดดังนั้นเนี่ยเลือกใช้ขั้นต่ำที่150ชุดค่ะแล้วก็ทำการเก็บข้อมูลมาได้เนี่ยทั้งหมด157ชุดค่ะโดยแต่ละตัวแปรเนี่ยมีคำถามดังตารางด้านขวามือค่ะผลการวิเคราะห์ EFA นะคะจากการทดสอบค่า KMO เนี่ยค่า KMO ก็คือค่าความเหมาะสมของข้อมูลนะคะควรมากกว่า 0.8 ค่ะการศึกษานี้ได้ 0.857 ค่ะก็ถือว่าผ่านนะคะค่าความแปรปรวนสะสมค่ะควรมากกว่า60นะคะการศึกษานี้ได้ 70.346 ค่ะก็ถือว่าผ่านเกณฑ์นะคะโดยค่าน้ำหนักปัจจัยและค่าความร่วมกันนะคะที่ได้จากการวิเคราะห์ EFA เนี่ยเป็นดังตารางด้านขวามือเลยค่ะก็จะเห็นได้ว่าแต่ละตัวเนี่ยมากกว่า 0.5 นะคะก็ถือว่ามีค่าน้ำหนักปัจจัยที่มีน้ำหนักพอสมควรค่ะผลการวิเคราะห์ CFA นะคะจากการตรวจสอบค่าความสอดคล้องของแบบจำลองนะคะก็ผ่านเกณฑ์นะคะแล้วก็เมื่อดูผลนะคะด้านขวามือเนี่ยจะเห็นว่าตัวแปร4นะคะการทำงานที่บ้านทำให้ทำงานได้อย่างมีประสิทธิภาพเนี่ยส่งผลต่อ personal มากที่สุดนะคะก็คือ 0.79 ค่ะแล้วตัวแปรที่7นะคะเพื่อนร่วมงานของท่านทำงานที่บ้านในช่วงโควิด -19 ระบาดนะคะส่งผลต่อ normative มากที่สุดนะคะคือ 0.94 ค่ะผลการวิเคราะห์ SEM นะคะจากการตรวจสอบค่าความสอดคล้องของแบบจำลองถือว่าผ่านเกณฑ์นะคะผลด้านขวามือนะคะจะเห็นได้ว่าตัวแปร4เนี่ยการทำงานที่บ้านทำให้ทำงานได้อย่างมีประสิทธิภาพส่งผลต่อ personal มากที่สุดนะคะก็คือ 0.81 ค่ะตัวแปร7นะคะเพื่อนร่วมงานของท่านทำงานที่บ้านในช่วงโควิด -19 ระบาดนะคะส่งผลต่อ normative มากที่สุดนะคะก็คือ 0.94 ค่ะแล้วก็ personal นะคะส่งผลต่อความตั้งใจที่จะ work from home มากที่สุดนะคะก็คือ 0.54 ค่ะและ normative นะคะส่งผลต่อความตั้งใจที่จะทำงานที่บ้านนะคะ 0.23 ค่ะจากผลที่ได้จากการเก็บข้อมูลนะคะ 6.37% เห็นด้วยอย่างยิ่งที่จะทำงานที่บ้านบ่อยกว่าช่วงก่อนโควิด -19 ค่ะ 24.84% เห็นด้วยที่จะทำงานที่บ้านบ่อยกว่าช่วงก่อนโควิด -19 ค่ะและ 45.86% เนี่ยค่อนข้างเห็นด้วยที่จะทำงานที่บ้านบ่อยกว่าช่วงก่อนโควิด -19 ซึ่ง เมื่อรวม3กลุ่มนี้แล้วเนี่ยจะแสดงให้เห็นถึงร้อยละของกลุ่มตัวอย่างที่ตั้งใจที่จะทำงานที่บ้านบ่อยกว่าช่วงก่อนโควิดค่ะก็คือร้อยละ 77.07 ค่ะการอภิปรายนะคะปัจจัยที่ส่งผลต่อความตั้งใจที่จะทำงานที่บ้านหลังจากสถานการณ์โควิด -19 คลี่คลายมากที่สุดคือปัจจัยที่เกี่ยวกับตนเองค่ะโดยเฉพาะอย่างยิ่งการทำงานที่บ้านทำให้ทำงานได้อย่างมีประสิทธิภาพค่ะซึ่งไม่สอดคล้องกับทารุเจนนะคะที่พบว่าการรับรู้ความสามารถในการควบคุมพฤติกรรมและการคอยตามกลุ่มอ้างอิงเป็นตัวแปรสำคัญที่ทำให้เกิดความตั้งใจที่จะทำงานที่บ้านหลังการระบาดของโรคโควิด -19 ส่วนเจตคติหรือทัศนคติเป็นตัวแปรที่ส่งผลค่อนข้างน้อยค่ะต่อเจตนาในการทำงานที่บ้านหลังการระบาดของโรคโควิด -19 ค่ะการศึกษานี้นะคะยังพบว่ากลุ่มตัวอย่างส่วนใหญ่ 77.07% เนี่ยต้องการที่จะทำงานที่บ้านบ่อยกว่าช่วงก่อนโควิด -19 ค่ะสรุปผลนะคะปัจจัยเกี่ยวกับทัศนคติเกี่ยวกับการทำงานที่บ้านเช่นการทำงานที่บ้านเนี่ยเป็นการทำงานที่มีประสิทธิภาพนะคะทำให้มีความสมดุลระหว่างการทำงานกับการใช้ชีวิตมากขึ้นนะคะมีการใช้เวลาอย่างคุ้มค่าค่ะมีแฟกเตอร์โหลดดิ้งอยู่ที่ 0.54 นะคะแล้วก็ปัจจัยเกี่ยวกับงานและผู้เกี่ยวข้องนะคะเช่นลักษณะงานสามารถทำงานที่บ้านได้ค่านิยมการทำงานที่บ้านของเพื่อนร่วมงานเนี่ยมีแฟกเตอร์โหลดดิ้งอยู่ที่ 0.23 ค่ะก็สามารถสรุปได้ว่าการทำงานที่บ้านให้มีความสะดวกและมีประสิทธิภาพนั้นบ้านที่อยู่อาศัยและสภาพแวดล้อมเนี่ยมีความสำคัญเป็นอย่างยิ่งนะคะและสามารถนำไปสู่แนวคิดการพัฒนาที่อยู่อาศัยนะคะเพื่อรองรับการทำงานและการใช้ชีวิตวิถีใหม่ที่มีประสิทธิภาพต่อไปค่ะองค์กรนะคะสามารถนำผลได้จากการศึกษานี้ไปต่อยอดในการกำหนดนโยบายการทำงานของพนักงานได้ด้วยค่ะข้อเสนอแนะเพิ่มเติมนะคะควรทำการศึกษาปัจจัยด้านการเดินทางเพิ่มเติมนะคะเนื่องจากการทำงานที่บ้านทำให้ประชาชนเนี่ยไม่จำเป็นต้องเดินทางออกจากที่พักอาศัยเพื่อเป็นประโยชน์กับภาครัฐในด้านการคมนาคมต่อไปค่ะก็ขอจบการนำเสนอเพียงเท่านี้ค่ะขอบคุณค่ะ
Thank you for your presentation. This study showed the result, the personal effect, that is the highest effect to intention to work from home. Okay, let's move for the next presenter. Next presenter is Mr. Anuwat Chacharapong. Please.
Hello everybody, I am Anuwat Checharapong from University of Technology, Sulanadi University of Technology. I will present topic that gap acceptance for U-turn median opening on intercity highways. Introduction. In Thailand, several arterial highways are 4-lane roads with a median. However, when the driver wants to exit the area on the opposite side of the road, they must use the U-turn median opening with unsignalized. The heavy traffic on the main road usually cause vehicles requiring the U-turn to wait for a long time. And it may cause driver risky behavior that try to merge and constrain vehicle on main road to slow down and stop suddenly, which may cause danger to road users. This study aimed to investigate the gap acceptance behavior at the U-turn median opening with unsignalized intersection on intercity highway. In literature reviews, this research indicate that the waiting time for reversal doesn't affect the critical gap. That may be because the study site was in urban area with a small proportion of truck, whereas a large proportion of heavy truck often occur on the interstate highways. Yeah. More research for study in the interstate road is needed due to different driving behavior. Next, the study focused on gap extent behavior at U-turn median opening on 4-lane road. The results show that male driver accept shorter gap than female driver. The same for younger driver, accept gap shorter than older driver, and waiting time have an impact on driver gap acceptance behavior. That is, driver tend to accept shorter gap due to a long time in U-turn. In data collection, observed on Friday and Saturday for 8 hours from 8 a.m. to 4 p.m. on 4-lane and 6-lane interstate highway. The type of vehicle grouped by 3 main categories. One is light vehicle, medium vehicle, and heavy vehicle. In geometric characteristic, the U-turn median opening with unsignalized on 4-lane and 6-lane intercity highways. The location, the site on intercity highway was reserved heavy vehicle take the U-turn is chosen. This study used the logic model to analyze gap acceptance. The results show that data description, the number of vehicles taking a U-turn is 2,128 vehicles, including light vehicle 7.94%, medium vehicle 75.98%, heavy vehicle 16.17%. In mean gap and waiting time, heavy vehicle are the most are the highest. Yes. The results are about logic model. Model 1 is overall model consider gap, size of gap, waiting time, geometric characteristic, and type of vehicle. Model 2 and Model 3 are separate on geometric, based on geometric characteristic. Yes. By Model 2 is 4-lane highway, Model 3 is 3-lane highways. Model 4 to 6 are model separate or based on type of vehicle. By Model 4 is light vehicle, Model 5 is medium vehicle, and Model 6 is heavy vehicle. The conclusion, this research examined the gap acceptance behavior at U-turn median opening with unsynchronized on intercity highway by analyzing various factors and using the logic model. The first model includes all the factors used to predict gap acceptance, which consists the type of vehicle, geometric characteristics of road, size of gap, and waiting time. In overall model, when gap increases, increasing the gap of vehicle on major roads result in increasing the probability of gap acceptance, the waiting time has a longer than is associated with the probability of gap acceptance. The number of lane increased from 4 to 6 lane highway will increase the probability of gap acceptance. The medium and heavy vehicle tend to accept large gap than light vehicle. The other model's waiting time is doesn't significant for light vehicle. The number of lane for light vehicle is effect to probability gap acceptance increasing, whereas medium vehicle and heavy vehicle reduce the probability of gap acceptance. Thank you.
Thank you for your presentation. Are there any questions?
Thank you for presentation. I'm very interested about the program at the U-turn, especially in Thailand. We also try to study similar things, but in my experience, that the not only gap acceptance, sometimes like a motorcycle or small vehicle come after the heavy vehicle. So I always think that like a blind spot is a very how to say used to be the reason of traffic accident. So behavior of the vehicles at the U-turn section is very complicated. I think like this. So how do you analyze? Because sometimes car come, but another car come beside, and from the blind spot they come out, right? So even we say the gap acceptance, but the behavior is a little bit complicated. So
gap acceptance.
Not only gap acceptance, I think that the other factor also influence to the accident at the intersection, U-turn section. Thank you.
Again, please.
No, I think not only gap acceptance, other factor influence to the traffic accident at the U-turn section.
Yes, there is speed on major road.
The one is maybe blind spot because because from this car, the heavy vehicle try to U-turn and stop, right?
Yeah.
And we can also see the behind the heavy duty truck, but suddenly motorcycle come out or some other car come out.
Yes.
Right.
Right.
So I think that the many cases we can expect. So yeah, but anyway, interesting. About your study.
Thank you very much.
Any question? Okay. The last presenter of today. I introduce Mr. Supasawat Saingam. She will present online. Okay, please.
สวัสดีครับผมนายสุภัทรวัฒน์สายงามวันนี้จะมานำเสนอหัวข้อเรื่อง Impact Analysis of Differential per lane speed limit on multi-lane highway using Microscopic Traffic Simulation Model หรือการวิเคราะห์ผลกระทบของการกำหนดขีดจำกัดความเร็วตามช่องจราจรที่แตกต่างกันบนทางหลวงด้วยแบบจำลองจราจรระดับจุลภาคครับการกำหนดขีดจำกัดความเร็วตามช่องจราจรที่แตกต่างกันหรือเรียกว่า Differential per lane speed limit เป็นวิธีการจัดการควบคุมการจราจรหรือความเร็วของยานพาหนะบนถนนวัตถุประสงค์ของ Differential per lane speed limit คือการแยกยานพาหนะที่วิ่งด้วยช่วงความเร็วที่แตกต่างกันในช่องจราจรที่แตกต่างกันและลดความเร็วของยานพาหนะที่แตกต่างกันในแต่ละช่องจราจรในปัจจุบันประเทศไทยได้มีการกำหนดอัตราการใช้ความเร็วของยานพาหนะบนทางหลวงให้มีขีดจำกัดความเร็วตามช่องจราจรที่แตกต่างกันในหลายสายทางเช่นทางหลวงหมายเลข1หมายเลข32หมายเลข34เป็นต้นโดยการกำหนดอัตราความเร็วสูงสุดที่120 กิโลเมตรต่อชั่วโมงใน และใช้ความเร็วไม่ต่ำกว่า100 กิโลเมตรต่อชั่วโมงในช่องจราจรขวาสุดโดยทางหลวงหมายเลข32เป็นเส้นทางแรกที่มีการนำร่องขีดจำกัดความเร็วตามช่องจราจรที่แตกต่างกันทางผู้วิจัยนะครับมีความสนใจในการศึกษาผลกระทบของการกำหนดขีดจำกัดความเร็วตามช่องจราจรที่แตกต่างกันโดยประยุกต์ใช้แบบจำลองจราจรด้วยโปรแกรม PTV Wisdom ครับงานวิจัยนี้มีวัตถุประสงค์เพื่อพัฒนาแบบจำลองจราจรของสภาพจราจรภายใต้การกำหนดขีดจำกัดความเร็วตามช่องจราจรที่แตกต่างกันและวิเคราะห์ผลกระทบของการกำหนดขีดจำกัดความเร็วตามช่องจราจรที่แตกต่างกันที่มีต่อพฤติกรรมการใช้ความเร็วพฤติกรรมการเปลี่ยนช่องจราจรและประสิทธิภาพด้านการจราจรครับการดำเนินงานวิจัยนะครับจะมี6ขั้นตอนครับผมโดยขั้นตอนที่1ก็คือศึกษาและก็ทบทวนงานวิจัยที่เกี่ยวข้องขั้นตอนที่2ก็คือการสำรวจและเก็บรวบรวมข้อมูลขั้นตอนที่3ก็คือพัฒนาแบบจำลองจราจรระดับจุลภาคขั้นตอนที่4ก็คือการวิเคราะห์ข้อมูลขั้นตอนที่5ก็คือประเมินและเปรียบเทียบประสิทธิภาพและขั้นตอนที่6ก็คือสรุปของการศึกษาและข้อเสนอแนะครับการสำรวจและรวบรวมข้อมูลในงานวิจัยนี้เราจะใช้ทางหลวงหมายเลข32ช่วงถนนอยุธยาอ่างทองระหว่างกิโลเมตรที่4ถึงกิโลเมตรที่50เป็นกรณีศึกษาเพื่อสำรวจและรวบรวมข้อมูลโดยถนนดังกล่าวมีจำนวนทั้งหมด4ช่องจราจรขนาดช่องจราจรละ 3.5 เมตรไหลทางกว้าง 2.5 เมตรมีเกาะกลางแบบมีกำแพงคอนกรีตกั้นไม่มีจุดกลับรถและมีปริมาณจราจรเฉลี่ยรายวันอยู่ที่ 2,500 คันต่อวันและสัดส่วนรถบรรทุกอยู่ที่10%การสำรวจข้อมูลความเร็วของยานพาหนะในแต่ละช่องจราจรโดยผู้วิจัยได้เลือกจุดสำรวจกิโลเมตรที่ 37+175 บนสายทางในพื้นที่ศึกษาทั้งช่วงก่อนและหลังการดำเนินการกำหนดขีดจำกัดความเร็วตามช่องจราจรการพัฒนาแบบจำลองในงานวิจัยนี้ได้สร้างแบบจำลองจราจรระดับจุลภาคโดยใช้โปรแกรม PTV Wisdom เพื่อประเมินผลกระทบด้านการจราจรของการกำหนดขีดจำกัดความเร็วตามช่องจราจรโดยสร้างแบบจำลองจราจร2กรณีได้แก่กรณีแรกคือรูปซ้ายมือนะครับเป็นแบบจำลองของช่วงถนนที่มีการกำหนดขีดจำกัดความเร็วทุกช่องจราจรเท่ากันที่90 กิโลเมตรต่อชั่วโมงและรูปที่2ครับขวามือเป็นแบบจำลองของช่วงถนนที่มีการกำหนดขีดจำกัดความเร็วตามช่องจราจรที่แตกต่างกันโดยช่องจราจรขวาสุดมีความเร็วสูงสุดที่120 กิโลเมตรต่อชั่วโมงแบบจำลองจราจรทั้ง2ช่วงถนนที่ศึกษานะครับผมมีระยะทาง5 กิโลเมตรมีจำนวนทั้งหมด4ช่องจราจรไม่มีทางเชื่อมเข้าออกมีปริมาณจราจร 3,000 คันต่อชั่วโมงต่อทิศทางและสัดส่วนรถบรรทุกอยู่ที่10%และความเร็วของยานพาหนะก็ได้จากการสำรวจครับผลการศึกษาครับผลการวิเคราะห์พฤติกรรมการใช้ความเร็วบนทางหลวงที่ได้จากแบบจำลองจราจรพบว่าภายหลังการกำหนดขีดจำกัดความเร็วตามช่องจราจรที่ปรับเพิ่มขีดจำกัดความเร็วเป็น120 กิโลเมตรต่อชั่วโมงพบว่าพฤติกรรมการใช้ความเร็วมีแนวโน้มสูงขึ้นความเร็วเฉลี่ยเพิ่มขึ้นจาก98เป็น101 กิโลเมตรต่อชั่วโมงความเร็วที่ 85% ไทยเพิ่มขึ้นจาก83เป็น89 กิโลเมตรต่อชั่วโมงและมีการใช้ความเร็วของยานพาหนะในแต่ละคันใกล้เคียงกันมากยิ่งขึ้นโดยส่วนเบี่ยงเบนมาตรฐานของความเร็วลดลงจาก 12.2 เป็น 11.8 คือถ้าพิจารณาความเร็วแยกตามช่องจราจรของยานพาหนะจะพบว่าความเร็วในแต่ละช่องจราจรเพิ่มขึ้นดูจากกราฟการแจกแจงความถี่สะสมของความเร็วยานพาหนะครับผลการศึกษาในการเปลี่ยนช่องจราจรครับผมรูปซ้ายนะครับคือการแจกแจงความถี่ของจำนวนครั้งในการเปลี่ยนช่องจราจรพบว่าการกำหนดขีดจำกัดความเร็วตามช่องจราจรพฤติกรรมการเปลี่ยนช่องจราจรมีแนวโน้มลดลงโดยที่ก่อนดำเนินการกำหนดขีดจำกัดความเร็วตามช่องจราจรเนี่ยยานพาหนะส่วนใหญ่จะเปลี่ยนช่องจราจรอย่างน้อย 1-2 ครั้งครับผมแต่หลังจากดำเนินการกำหนดขีดจำกัดความเร็วตามช่องจราจรแล้วเนี่ยยานพาหนะส่วนใหญ่จะไม่เปลี่ยนช่องจราจรตลอดเส้นทางครับรูปขวานะครับคือจำนวนครั้งของการเปลี่ยนช่องจราจรของยานพาหนะแยกตามช่องจราจรพบว่ารูปแบบทิศทางของการเปลี่ยนช่องจราจรมีความเป็นระเบียบมากขึ้นโดยหลังจากการกำหนดขีดจำกัดความเร็วตามช่องจราจรสัดส่วนของยานพาหนะที่เปลี่ยนช่องจราจรไปด้านขวามีมากกว่าเปลี่ยนช่องจราจรไปทางด้านซ้ายในขณะที่ก่อนดำเนินการมีสัดส่วนจำนวนยานพาหนะที่เลือกเปลี่ยนช่องจราจรทั้งซ้ายและขวามีความใกล้เคียงกันครับประสิทธิภาพการให้บริการครับผลวิเคราะห์คุณลักษณะของการจราจรโดยเปรียบเทียบความสัมพันธ์ระหว่างอัตราการไหลและความเร็วของยานพาหนะในแต่ละช่องจราจรก่อนและหลังดำเนินการกำหนดขีดจำกัดความเร็วตามช่องจราจรพบว่าภายหลังการดำเนินการกำหนดขีดจำกัดความเร็วตามช่องจราจรกระแสจราจรสามารถเคลื่อนตัวได้มากขึ้นเนื่องจากมีขีดจำกัดความเร็วที่สูงขึ้นโดยเฉพาะช่องขวาสุดที่มีการปรับความเร็วเป็น120 กิโลเมตรต่อชั่วโมงโดยมีอัตราการไหลสูงสุดเพิ่มขึ้นจาก 2,200 เป็น 2,500 คันต่อชั่วโมงหรือเพิ่มขึ้นประมาณ10%ของอัตราการไหลสูงสุดก่อนกำหนดขีดจำกัดความเร็วตามช่องจราจรครับสรุปผลการศึกษาและข้อเสนอแนะนะครับสรุปผลการศึกษาจะออกเป็น3ส่วนได้แก่การใช้ความเร็วการเปลี่ยนช่องจราจรประสิทธิภาพการให้บริการโดยการใช้ความเร็วเนี่ยหลังการกำหนดขีดจำกัดความเร็วตามช่องจราจรจะมีแนวโน้มการใช้ความเร็วที่สูงขึ้นเมื่อพิจารณาจากความเร็วเฉลี่ยและเปอร์เซ็นต์ไทยที่85เพิ่มขึ้นเฉลี่ยร้อยละ 3.26 และ 6.57 และการใช้ความเร็วของยานพาหนะรายคันจะเกาะกลุ่มกันมากขึ้นเนื่องจากพฤติกรรมการใช้ความเร็วของยานพาหนะ ในแต่ละช่องจราจรมีความใกล้เคียงกันการเปลี่ยนช่องจราจรผลการวิเคราะห์พฤติกรรมการเปลี่ยนช่องจราจรพบว่ากรณีหลังการกำหนดขีดจำกัดความเร็วตามช่องจราจรมีพฤติกรรมการเปลี่ยนช่องจราจรลดลงโดยอัตราการเปลี่ยนช่องจราจรของยานพาหนะลดลงจาก 2.2 ครั้งต่อคันเป็น1ครั้งต่อคันประสิทธิภาพการให้บริการหลังการกำหนดขีดจำกัดความเร็วตามช่องจราจรที่แตกต่างกันพบว่ากระแสจราจรมีความคล่องตัวมากยิ่งขึ้นเนื่องจากการกำหนดขีดจำกัดความเร็วที่สูงขึ้นโดยอัตราการไหลสูงสุดเพิ่มขึ้นร้อยละ 13.6 จากผลการศึกษานี้แสดงให้เห็นว่าการกำหนดขีดจำกัดแยกตามช่องจราจรทำให้ผู้ขับขี่สามารถใช้ความเร็วได้อย่างเหมาะสมตามช่องจราจรและมีความสอดคล้องกับลักษณะทางกายภาพและการใช้งานของผู้ขับขี่ข้อเสนอแนะในงานวิจัยนี้วิเคราะห์ภายใต้สมมติฐานที่ถนนทางหลวงมีลักษณะทางกายภาพคงที่ไม่มีทางเชื่อมหรือจุดเปิดกลับรถตลอดเส้นทางและผู้ขับขี่ยานพาหนะปฏิบัติตามขีดจำกัดความเร็วตามช่องจราจรที่กำหนดไว้ส่งผลให้พฤติกรรมการใช้ความเร็วสอดคล้องกับขีดจำกัดความเร็วที่กำหนดงานวิจัยในอนาคตควรมีการศึกษาเพิ่มเติมด้านการพัฒนาแบบจำลองให้สอดคล้องกับสภาพจริงมากยิ่งขึ้นเช่นการใช้ความเร็วตลอดแนวเส้นทางและควรมีการพิจารณาทางเชื่อมที่อาจส่งผลต่อความเร็วที่ลดลงได้ขอจบการนำเสนอเพียงเท่านี้ครับ
Thank you for your presentation. Are there any questions? Okay. I have a little question. In my city, Khon province, we have the speed automatic camera. We can control the speed is reduced and is high the flow, but it's different for this research. Can you tell me about why the difference for the result between your research and the content project? Your research show that high flow and high speed, but in my province project, I can control the speed. You can tell me about why the different the result.
ก็มันจะส่งผลทำให้ความเร็วของช่องจราจรที่แตกต่างกันนะครับทำให้รถใช้ความเร็วกับช่องจราจรที่เหมาะสมครับมันจะทำให้ความเร็วของช่องจราจรนั้นมีความใกล้เคียงกันมากขึ้นครับจะทำให้รถไม่สามารถอย่างวิ่ง90อย่างเงี้ยครับจะไปแช่ช่องขวาหรือแช่ช่องที่2นะครับอย่างเงี้ยมันจะทำให้รถคันข้างหลังที่วิ่งมาด้วยความเร็วครับก็จะต้องชะลอตัวตามหรือว่ารอแซงครับแต่ถ้าเรากำหนดขีดจำกัดความเร็วตามช่องจราจรแบบนี้ครับมันจะทำให้รถเนี่ยสามารถใช้ความเร็วของแต่ละช่องจราจรนั้นๆให้มันสัมพันธ์กับความเร็วที่ของผู้ใช้ทางใช้อยู่ครับจะทำให้มีความคล่องตัวมากยิ่งขึ้นเลยครับ
How will you deal with the real situation that if the people did not follow by the rule, right? They not you specific that more than 100 kilometer per hour should die on the live lane, right? But if they die less than 100, how can you will check or how you will like enforce them to drive following by the rule?
ใช่ครับหลังแบบจำลองก็จะทำให้ทุกคนพยายามทำตามกฎที่ตั้งไว้ในแต่ละช่องจราจรมากที่สุดครับ
Yes, in the simulation they following by the rule, but in the real life, do you have any idea how you will control the people?
ก็ถ้าของจริงก็น่าจะต้องใช้กฎหมายครับบังคับใช้ให้ผู้ขับขี่นะครับใช้ความเร็วตามกฎหมายกำหนดครับผม
So we may have to install the speed camera or speed detector, right?
อาจจะต้องเป็นใช้กล้องจับความเร็วอย่างเงี้ยครับแล้วก็ทำการ ปรับหรือว่าดำเนินตามกฎหมายครับเพื่อให้ผู้ใช้ทางเนี่ยสามารถไม่ฝ่าฝืนกฎหมายครับ
Okay, thank you.
Thank you for your presentation. อาจารย์น้อยหน่อยครับ
นั่นขอยิ้มหน่อยได้ไหมคะOkay. Yes. So you finish sessions? Okay, thank you very much today. So this is the last session, and I hope you not feel so exhausted listening to the end of the session. There is something waiting for you surrounding this area, so you can enjoy some dinner at we have Icon Siam department store. If you want to go, yeah, please feel free to do so. And before that, I would like to invite our honorable advisor once again, Mr. Silapachai, to present a token of appreciation to our session chair, as Assistant Professor Dr. ให้ท่านนี่ค่ะเชิญค่ะ Okay, thank you very much. So the Atrans Young Researchers Forum 2022 for the paper presentations finally has come to this end. I would like to thank you to everyone for making an excellent presentations. We still have some best paper and presentation award, but the result will not be announced today. It's going to be tomorrow. Okay, tomorrow is your big day. If you do not come to the conference tomorrow, you cannot receive any best paper, best presentation award. Okay, so today is a big day, and I think you feel so exhausted. So hopefully you have a good night, have a good rest tonight. And before closing the sessions, I'd like to thank you once again to the session chair and to the student committee and to our honorable advisor, Mr. Silapachai, and last but not least to all of you, and to ES flew all the way from Japan to join our AYF paper presentation today. Thank you very much. They are our big sponsor, so we have to give honor to them. And thank you very much. Some come very early morning. Thank you very much. And have a good rest tonight. And so thank you very much once again. Before leaving the hotel, can we have a good photo here? May I invite you all to have a good photo here? So come to the front, please. Come to the front, please. Let's have a good photo. Just in case next year we have COVID, at least we still have, some memorable photo taking together. Yeah, please come. You need some chair? Oh, too many people. Okay, the young generation can help Professor Fukuda to bring the chair so we can, have some more space taking photo together. Okay. Thank you. ขอบคุณค่ะ อันนี้ขยับน้องแพรขยับหน่อยลูกขยับน้องไปหน่อย Okay. Yes. Fukudan said leave. Okay. Maybe move the table backward. Okay. May we invite the youngest senior people take a seat. And the older young generation standing behind. The older young generation standing behind. And the youngest senior generation sitting front, please. Yes, the youngest senior generation, please. Yes, please. Please. Yes. อาจารย์วิโรจน์ค่ะไม่ต้องหลบค่ะอาจารย์ขาเชิญนะคะ ค่ะเชิญค่ะโอโนซังอาจารย์วรเมธเชิญนะคะไม่ต้องหลบ เลยสองที่พอดีเลยมาเลยค่ะมาค่ะอีกสองค่ะอีกสองค่ะ Alex you youngest senior generation come front please yes one more still one more left อาจารย์วรเมธค่ะมาค่ะอาจารย์ขาอาจารย์นักศิษย์มาเลยไม่ต้องหลบมาซะดีๆแวบเร็วอาจารย์ เร็วดูค่ะเดี๋ยวกำลังพูดอยู่ค่ะเร็วค่ะขออนุญาตเลยค่ะเอาลบอีก ไม่มีใครเลยเหรอเดี๋ยวนั่งเองงั้นโอเคนั่ง We will send the photo that taken today to you all, okay? Either maybe by email or by some live application, okay? So for AYA presenter, we will have only one van today. So we will send you to the hotel, 2 routes, okay? So first, who would like to go first? Just go out and our secretary will arrange transportation for you. Okay, make sure tomorrow you come to see us because I would like to see you all tomorrow once again. Don't leave me alone, please, tomorrow. I'd like to see you all face, okay? So tomorrow, the conference will start at 9. Oh, sorry, 9. What? On the 4th floor. I think you remember, right? You came last year. Oh, no, last 3 years. Take them all with you. Right. Excellent. So see you tomorrow. Okay, thank you. See you tomorrow. Oh, you want to take photo? Then feel free. Okay. Yes. I'll move this chair back so that they can see. Take a photo back. Return the chair. Return the chair.